Welcome back, everyone. We are here for day 2 of the completely free Certified Cloud Security Professional Bootcamp. My name is Michael Gibbs. I am one of your instructors today. I am joined here by Mark Milovanovic. Together, we have more than 35 years of knowledge and experience in network security and other forms of security and networking, and we're having a great time teaching this free bootcamp. So, if this is your first day, you can go back and watch the first day. Chris from my team will drop that link in the chat box, and that way you can go back and watch the entire thing. You can still join us today and go back and watch that then. It doesn't really matter the order, but just letting you know that it's there. A couple other things I want to do before we actually begin is to, you know, remind you that we have a free ebook to go with you on this course. And, my team wrote this book because we wanted you to have something that you could take notes on. We wanted you something that you could use as cheat sheets. We wanted you something to have something that you could use as a reference. So we wrote a book to help you pass the Certified Cloud Security Professional exam, that CCSP exam, and the book is completely free. Please make sure you get this book. Now, normally when we put a course together like this and a book together, it costs as much to produce as it was to buy a car. And we're happy to do that because we want to provide quality training to those that need it. But we want to get as many people access to this free training as possible. So my team made a LinkedIn post about this free book, which is where you can download it. If you want to help others and share our message and share this free ebook with others, please, like that post or share it or whatever, or just download your book there, whatever you want to do. But we want to get this book, this free book that we wrote, in the hands of as many people as possible. So help us spread the word. I'll turn it over to you real quick, Mark Milovanovic. He's our Chief Technology Officer. He's a CCIE like me, although from a different time period, and he has a wealth of knowledge when it comes to tech things. So, Mark, you'll introduce yourself, and then we'll get back to the fun.
Yeah, I hope everybody's excited as we are to be able to put on the second day of roughly about 10 days. It's going to last this bootcamp in regards to cloud security. Again, a vendor agnostic, a vendor neutral approach. Mike mentioned as well the study guide that we have or the ebook. Just so you guys understand, it is our way of paying it forward. And we're hoping that you guys will take the same spirit that we have taken, shared with those that you think could use it, and as well invite them to the various days of the bootcamp that we have. And something else that you can do is use it as your own slide deck in a sense. As we go through the material, follow along in the ebook as well, write down the notes that you have, make sure that you write down what questions you're going to have for us. And as always, we'll have a little Q&A session, maybe every 20 to 30 minutes. And what we'll try to do is we'll address, first of all, the questions that are going to be in scope, meaning those questions that are going to be associated with the content. And then as time permits, we'll tackle the remaining of those questions. Aside from that, I hope everybody's excited for this. Please give us a hashtag CCSP in the chat so that we know that you guys are ready to go and that you're excited for this. And aside from that, let's bring the energy for this. This is going to be fun for everybody.
Absolutely more fun. And on Thursday, like every Thursday, we have a How to Get Your First Cloud Architect Job webinar where we go over the role. We talk about what cloud architects actually do versus what people think they do. And believe me, it's a very different thing. We'll talk about all the things we do in our jobs, all the skills that you need, and that way you can build your career. And it's free. And we will also spend at least 90 minutes or so, about 60 to 90 minutes answering any questions you have. So join us. It's free, and it's on Zoom, so you can ask, literally speaking, any kind of question you want. And if you want us to assess you, check you, give you a quick interview, check something about your profile, we're happy to do it, and it's all free. So join us. So now we're going to get back to the content. So yesterday we actually kicked off a discussion on various forms of cloud computing and various forms of cloud architectures. And then we talked a lot about confidentiality and integrity and availability. And we talked about privacy and a few other things. And now we're going to get into something called maintenance and version control. So whenever we're dealing with technology, each piece of technology is going to have its strengths, its weaknesses, its limitations, and its flaws. And one of the things we have to determine when we're running systems is what type of platforms we're using. So let's say, for example, we have one good Linux build. And I don't care whose Linux it is, but this version of Linux that is relatively bug-free. It's relatively secure. The company is hacked that. By hacking it, I mean hacking the Linux. I mean removing unnecessary packages, making a good golden base image. Now, if they were to find out that there were issues with that image, they would move to a new image. And they wouldn't want to go back to that old image, and they'd need some form of version control. So whether it's when software is being written, whether it's the operating systems on our routers or our switches, whether it's the software versions being deployed, we need to make sure what's going on. But also with cloud computing, we have to understand that a lot of this is going to be delivered via infrastructure as code. So one person's going to write a Terraform script, and it's going to deploy resources all over the world pretty quickly. And with that, if the wrong script version is used, it can cause damage to the system. So version control and maintenance are going to be part of that operations things that are going to be critical for those in operations. And for those of us in architecture, it's part of our planning on what kind of way will an organization track their versions, track their architecture artifacts, etc. So no matter where you're at on the engineering side where you're going to be working on these versions, or the architect side where you're planning it, it's pretty important to know. So when we deal with organizations, they become very complex, and IT teams need to coordinate. Imagine an enterprise with 1,000 applications. It's not uncommon. 50,000 subnets in their, or 50,000 IP addresses, 5,000 subnets in their routing table, for example. These are the kinds of things that we're actually talking about. So we need to be very careful of these things. Because our role in some way, shape, or form needs to be a facilitator for an architect. And for the engineers, they need to be making sure this stuff actually happens. So we have to think about maintenance schedules. Now, in our data center, we have our own maintenance schedules, right? But in the cloud provider, they also have their own maintenance schedules. So we have to think about that from an operations perspective on the business side. The cloud provider needs to do an upgrade. They have some degree of planned downtime, potentially. Maybe they don't. And we can plan it in our data center when we do these upgrades, but that can't be planned in the cloud provider. So that's something I want you to think about as it deals with software development, data center maintenance, any of these things. Now, when we're dealing with cloud computing, we're dealing with outsourcing. We're just outsourcing that data center. If you weren't here yesterday, we really talked about data centers being buildings that are filled with power, two power companies typically, generators and backup generators and batteries. So that's how much goes into the power redundancy in these systems. And then when they have their networking gear and they have their servers and they have their storage and they have their physical load balancers, physical firewalls, etc. And in the cloud, we're renting a virtual version of that. So when we go from our systems, which we own, to the cloud, we just outsourced a lot of that. We outsourced that data center and infrastructure. So when we're planning these things, is that something we can choose to outsource? So when we deal with outsourcing, some things are really great and some things are not. So let's talk about the concerns with regards to outsourcing. Is it reversible? So if an organization has 500 virtual machines in their data center, and they take those 500 virtual machines and convert them to 500 EC2 instances in AWS, and it doesn't work out in AWS, they can go straight back to those same 500 virtual machines in their data center. No problem. By comparison, if they took the application they had, they completely refactored it to run on a provider systems and use potentially proprietary systems, can they leave that provider? They can, but it's going to cost a lot of time, effort, and money. So when we outsource, we have to think about how long we're going to be in that outsourcing relationship. Is it reversible? Can you get in and can you get out? Think of any business deal. You want to be able to get in, but you also want to be able to get out if things get bad. So we have to make sure we can build a rollback plan if absolutely necessary. So whatever we need to do to make that happen. Other challenges we have with outsourcing are vendor lock-in. So I alluded to it before, but it didn't go down here. One of the reasons most enterprises really can't use an AWS DynamoDB or an Azure Cosmos DB or a Google Cloud Bigtable, even though they're wonderful databases, they're great databases, is they're in more than one cloud. And each one of these databases is proprietary to some degree. But they can put MongoDB or Apache Cassandra in all of those clouds, and they don't have these problems. So when people move to the cloud, depending upon the choices they make, they can get themselves locked in. If you manage your own Kubernetes infrastructure across 2 data centers and 2 cloud providers, You've got no problem if things work out. What happens if you're using one of the cloud providers' managed Kubernetes services, and you have 3 clouds in a data center, and the cloud is controlling your entire Kubernetes infrastructure, and the cloud goes down? So there's that. But also, if you're your own Kubernetes thing, it's easy to get in, easy to get out. And Kubernetes makes it easier, even if you're using the cloud providers. But having your own, there's advantages as well. Not using managed databases, not using certain serverless things can prevent you from getting locked in. Of course, you might want to use some of these serverless things. So the question is, can you afford to get locked in? And if so, how could you do it? And there's lots of ways we can go cloud native, like running your own Kubernetes control plane and running your containers in each cloud. That's totally under your control and it's not proprietary. So there's ways we can optimize across platforms, but if we're not careful, we get locked into a certain vendor. If we use any of those proprietary things they teach us in a certification, it becomes hard to get out of the vendor. So if we're going to outsource, do we want to allow ourselves to get locked in? And if the answer is no, and usually it should be no, how do we not get locked in? And that makes it easy for organizations to change clouds if they need to, change providers, add additional providers. There's that. So think about that from that outsourcing issue, because it's real critical, and your C-suite is always thinking about this. Now, when we're outsourcing, we have to think about interoperability issues. So some solutions, software as a service, platform as a service, they tend not to be highly interoperable. So what does that mean? It means if you use too many of them on one cloud, it'll be hard for you to add a second cloud or go back to your data center. By comparison, if you don't use these proprietary systems and you use interoperable systems on the cloud or in your data center, you don't have any of those issues. So architecturally, when organizations have to outsource, they have to think, is there a benefit for me to get locked in? Some proprietary thing that can help my business do something much better? Or should I stay open to be able to deal with any provider at some point in the future? So this interoperability piece is huge. So, if an organization wants to move, what do they have to do to be able to do it? Now, another driver of cloud computing in this plane is actually machine learning and artificial intelligence. I don't want you to think artificial intelligence is new. It's not. The first AI systems I worked on were written by PhD statisticians, and they were in 2001. And AI has been around since a lot longer than that. So let's talk about what is machine learning. And machine learning basically is where we take statistical analysis principles and we use them to actually mine through data with technology. So the point here is to analyze trends from the data, make recommendations or inferences, categorize records, anything we can do to improve efficiency from learning. And machine learning is kind of a subset of artificial intelligence. The key here is that it's designed to sort of mimic human thought and processes in computers. So have a whole bunch of data, train on the data, and see what it can actually find. And obviously this is intro level because this is not an AI program, but you could see this level of depth on your exam. So we can talk about descriptive analysis, and that's something we can typically do with machine learning. So we can analyze thousands or millions of customer records to determine if we have a younger customer base or an older customer base. We can analyze and find preferences among our age groups, so we know how to send, say, targeted marketing to them or develop products in a price range that they're willing to have, various age groups, various demographics, various who's interested in what. So huge marketing and sales opportunities there. We often use machine learning for, say, predictive analysis. So we can look at existing data, predict future data. So we could be building a model to help an airline purchase fuel price contracts at the lowest cost possible. It's another type of application we would use for something like this. Banks use something like this all the time and have been for decades. So they can look at historical buying and selling patterns of various stocks and correlate that with various actions and news and economic cycles. And they can use that to make predictions, and these systems will buy and sell stocks based upon projected market volatility, news cycles, and what it thinks is going to happen. And many of these systems are highly profitable. Many of these systems have also lost a lot of money, but that's the typical kind of predictive analysis you see these systems using. With machine learning, another application might be prescriptive analytics. So it can maybe be to, say, optimize behavior by simulating various scenarios. So you can run various simulations to determine, say, for example, let's say we had a product that we wanted to sell. Simulation 1, this type of price, this type of marketing strategy. Simulation 2, this type of marketing strategy, et cetera, et cetera. And even predict the amount that it thinks will be sold at what price and what strategy. So it can save a lot of time, effort, and money running predictions. And, you know, we've been doing this in the data center for decades, but cloud computing typically makes it a little easier because the resources are typically there. So I can obviously go to NVIDIA and buy a bunch of H100s and H200s and put them in my data center and get them in a few months. But if I want to do something now, I can do it in the cloud immediately. It may actually be cheaper long-term to run my AI system in my data center. I can buy a system with, say, 8 NVIDIA H100s for, say, $300,000. That will cost me millions and millions of dollars to run in the cloud. But you know what? Maybe I need some of them in my data center, but maybe I need 1,000 GPUs for 3 weeks straight to train my model. So a company could send their data to the cloud. They could use all that capacity that's there, train their model, bring it back to their data center, or use vice versa. So architecturally, especially when it comes to AI and machine learning and generative AI and other AI use cases, AI agents, etc., the cloud provider has so much compute capacity and it's there and is ready to be used when you need it. So lots of organizations are using AI on the cloud. Many organizations will do it in the private cloud, but in either case, it's still going to be on the cloud. So the cloud provider, when we think AI, we think the amount of storage that's there. And typically speaking, obviously you can run your own data pipelines, and that's what a big enterprise would do, but the cloud providers also have a lot of data tools to help facilitate making AI simpler if your staff is less sophisticated, because many of the things are pre-made. So think about that, pre-trained models. Lots of those are nice reasons why so many companies are using the cloud for AI. Now, I'm going to actually discuss blockchain in the concept of cloud computing because that's actually what is part of your curriculum. Now, the whole intent with blockchain initially was to make sure there was not a central ledger. So it all came about initially from, say, cryptocurrency, and there were some people that were concerned that the banks hold the ledgers to pretty much all the money in the world. So they had started with Bitcoin, and the first point of Bitcoin was the ledger was going to be on everybody's computer system that actually participated in the blockchain spread throughout the world. And that way no one owned the data. Well, that's a distributed computing system. If we think blockchain in the cloud, that is the exact opposite of traditional blockchain because it's not distributed at all. It's centralized because the cloud, for the most part, is centralized things. But nonetheless, there's blockchain that can also be done on the cloud. Now, in this exam, you know, one of the major applications of blockchain you would think would be cryptocurrency, but blockchain can be used for so much more. That decentralized ledger and the fact that it's immutable, because every time there's some impediment on the blockchain, there's a hash, and the hash can verify the integrity of the message, makes it very good for a lot of things. So, initially designed for cryptocurrency, we can track property ownership records, for example, because the records could be stored in a specific place all over the world in a public repository, so and not damaged along the way. We typically can use blockchain for supply chain tracking, so to make sure certain things don't get lost on the way. Making sure parts of the supply chain, because imagine you're a producer of something and one of your things isn't getting there because it's getting lost, and it's getting lost for a specific reason. That can be easily found out on the blockchain. While we're at it, drug diversion. You know, a drug company is trying to send its medications to the pharmacies so that people that need it can get these medications, and meanwhile, somebody steals the drugs and then sells them in the underground. Blockchain can find where things are going. It makes sure that little bits and pieces of deliveries just don't go missing, which sadly happens too much. Blockchain could be used for vital records because it could track a document like a passport or a birth certificate or sadly even a death certificate, but any type of application like that. So in cloud computing, why might it be used? Because it provides a global and scalable and distributed environment. Not very distributed compared to a traditional blockchain, which might be on millions of people's systems, but it's somewhat distributed, various regions, data centers, what have you. Another reason organizations are going to public cloud providers are Internet of Things. Now, I've been working with Internet of Things for almost 20 years. So we've been dealing with Internet of Things longer than we've had cloud computing. And Internet of Things can be done in the private data center, 5G data centers, and other environments. But Internet of Things can be also done in the cloud provider. So what is Internet of Things? For the most part, any type of device that's got an IP address. It's not your computer. So your refrigerator, which talks to you, that you can do a Google search on, is Internet of Things. The little weather sensors that are out there that send messages via an IP address about their weather is Internet of Things. The talking, walking robot cat that you have that has an IP address is the Internet of Things. So for the most part, that's what we're actually talking about. And the Internet of Things typically needs something to control them, and they typically need the device, and the cloud providers have a lot of pre-made packages to help make this easier. And Internet of Things can, let's talk about them in the context of security challenges. So if we're trying to lock down our systems, and we know that we've got a specific kind of computer hardware that's running a specific type of software that's got a specific type of anti-endpoint protection that's sitting behind whatever security policy we have. We can update that we can tune it. But Internet of Things makes it a little bit harder. A lot of those Internet of Things devices, it's very challenging to update the software on them. Because what they're doing is they're running a very skinny version of a traditional operating system, but it's going to lack a display, it's going to lack a keyboard, and it's going to be really hard to figure out what versions of software these things are running. And you have to understand that now we've got an IP-enabled device that's plugged into the network, and if they're compromised, you can compromise the network. So understand there's some security challenges around Internet of Things, especially if they're connecting to the same network with the same set of IP addresses as other systems. Now, it's possible for you to separate the IoT traffic from the traditional traffic, pop the IoT traffic, for example, in a different VLAN, and don't allow routing between those VLANs is one way you could do it and firewall off that. But many organizations just attach things to their Wi-Fi sensors or their 5G sensors or whatever they have going on, and poof, you've got an IP address, they're on the same subnet. You hack into one of these IoT things, and now you've hacked into the network. And this stuff is very hard to work with. To try to do this, because, you've got these, you could have one compromised smart device, and that could actually even turn into a router or a gateway to the rest of your system. So not something you really want. So these kind of smart devices typically connect to a edge data center, usually, because often they connect through the mobile phone network, and they're connecting to the mobile phone network. You can put some servers in that mobile phone network, and you've got a network. And the latency is relatively low that way. So that's one of the things. Now, the same thing, we could bring it back to the cloud providers network, because the cloud providers, for the most part, got internet connectivity. They've got a lot of internet peering points all over the entire world. So we can do that too. But again, anytime we've got these IoT devices, if they're not properly secured, they can actually compromise our security. So I want you to think about them. Now, earlier on the first day, when we talked about virtualizations, we talked about virtual machines. Now we're going to introduce the concept of containers. And I know there's a lot of fundamentals about cloud computing before we actually get to the security things. And I promise you, once we get to data, it's going to get a little geeky, a little too geeky for my taste, and I'm going to be begging you to stay awake. But we've got to build those foundations first. So a container is another virtualization option. And I'll show you why we use containers. So let me kind of whiteboard that out for you just in case. So let me come over here. So if I go to my whiteboard, if you'll recall yesterday in our traditional virtualization environment, we've got our physical server itself, the actual hardware. And from here, what we have is we typically have our hypervisor, And then we create our virtual machines. Now, I also yesterday walked you through a physical server in my house running VMware in a type 1 hypervisor environment like this. If you haven't seen it, you can go back. But typically what you see is these virtual machines. And let's say you make this virtual machine have 8 cores and say 16 or 32 GB DRAM. These virtual machines are going to pull this from the server's physical memory. Now this virtual machine will then have to run its own operating system. You'll see why we like the containers. And then it will have to run the application's dependencies. And then it will run the actual app. So what I mean by, so for example, there's video games, and I think they use some kind of DirectX, something, they use a couple drivers and things that need to be installed. So if somebody was going to install a video game, I don't play video games, but I know my brother does. He installs something, and then it puts some dependencies on his computer, a whole bunch of other stuff that his game needs to run, and then he runs the game. And then if he, on this server, if for example, if we wanted to do something else, maybe this thing is running a database, maybe this virtual machine is running a web server, maybe this virtual machine is doing whatever. Here's the key to note. Each one of these virtual machines requires its own operating system. And running an operating system is heavy in terms of the compute that it actually takes from the system. So if we've got 8 cores here and 32 gigs of RAM, the operating system may take 1 or 2 of those cores just to run the operating system, specifically if it's a Windows Server system. And it might take 4 to 8 gigs of RAM just to run the operating system. So that means we lose memory a lot faster, and we lose a lot more CPU cycles a lot faster, which means we can only put so many virtual machines on a container. Now, by comparison, if we had this, and we could have the hypervisor here or not, it really doesn't matter in a containerized environment. But let's say this was our virtual machine. And we could have another virtual machine over here too. Let's pop 2 virtual machines sitting on this server. What we can do here, and let's say that we can actually install the application dependencies. And I'll show you what I mean, or describe what I mean. And then we have the application, which is the actual software itself. Let's just say app. And then I can pack that neatly into this little box called a container. And I'm going to show you exactly what we're talking about here. So we've got this box called a container. And basically what we're dealing with is, I'm actually missing a layer I want to show you. Should have drawn it the first time. So let me show you the virtual machine will have its OS. And the virtual machine will have a container engine, which is basically something that lets you virtualize the operating system so that each container can stay isolated from the other containers. And this is basically called, this is a container runtime module. Docker is an example of this. And that way we can have our app and our app dependencies, and we can have another container, which is the app and its app dependencies, and we can have another container and its app dependencies. And now if we've got a server, for example, that has 384 cores and 8 terabytes of DRAM, we may be able to put hundreds, if not thousands, of small containers on that one server. And if we had to run the operating system and have virtual machines, we might be able to do half of that. So the point is containers are highly efficient because each copy of the container doesn't need its own operating system. So basically, we've got this little container that's independent of its hardware. Now, my developer makes this little container. I have the container runtime module on my system. I pop it on my system. I want to move it. I take that container, I pick it up and move it to another server. So pretty easy stuff that we're talking about. Containers are very nimble. And that's the reason why. So that's what we're talking about with regards to containers. They're lighter weight than traditional machines. And some things we want to talk about is the container will basically share the host's operating system instead of having its own. So they're pulling operating system libraries when needed by the container and the container's application dependencies. Each container is isolated from each other container. So if something happens in one container, it should not affect something in another container. Should not. But it should not, one container should not impact another container. But what happens if the operating system crashes? Everything goes down. So we have to understand that it's a secure environment, but it's not quite as secure as a virtual machine where each one has its own separate memory, its own separate CPU resources, and its own separate operating system. So it's highly secure, but not quite as secure. And think about that. And the last thing that I thought we would talk about in containers, it's not part of the CCSP curriculum, but it's something you probably do need to know, is containers like networking. There's basically two parts of them. So we need something that's called the control plane, and I'll explain what that is. And what the control plane does is it orchestrates the container management system. So if we tell the control plane that we need 5 containers running this specific package, the control plane will make sure there's 5 containers. One of the containers crashes, it will start a new container. So kind of think about that. That's the point of orchestration. Auto scaling is needs to be performed by the control plane. So the control plane does orchestration. And then basically speaking, we have the data plane or the compute plane. So this basically is where the container is going to run. So this is the actual server. And whether it's containers running on side of a virtual machine, which is totally a way which is the way it could be done, or whether we're dealing with a cloud provider's serverless environment, it's still going to be running on a server. You're just not going to know where the servers are. And that's how this type of control plane works. This sends messages to add containers when necessary, close containers, scale, auto scale. And that's the control plane. Now, typically speaking in today's world, the control plane is Kubernetes. And that's your standard industry standard control plane that will manage your containers. And you can use Kubernetes in your data center, your cloud provider. It can manage your containers on a server, physical server, virtual machine, or in any type of cloud provider serverless container system. It really doesn't matter. But that's typically what's going on. So kind of hope that will kind of help out a little bit. All right. You know what? Before we talk about anything else, I think it's been 20 to 30 minutes since we've begun today. So let me see if there's any questions that we need to address. Any questions for us thus far?
All right, we have a question from Chris Blackwell. He's wondering, from a security perspective, is there a preference when considering virtual machines versus container?
So every decision we must make needs to be based upon our customers' business requirements. If we create an environment that's so secure that the business goes out of business, we didn't do them any favors. So there's never a time for us that we can ever have a preference as an architect. I want to explain what a preference actually is. A preference is a surgeon, for example, who every patient that walks into that surgeon's office, whether they need surgery or not, gets the same surgery. That is what happens when we ultimately have a preference. We have a bias and we unfortunately never get to the right solution, or we're like a broken clock where it's right at 12 a.m. and 12 p.m. when it just happens to be lucky. We can't have that preference. Technically, there's a little bit more security in a virtual machine than a container, but there's lots of ways we can provide the security we need. It's not just one device versus another. We've got so many other options that we have along the way. So whatever the business needs are. Because if we lock in a customer based on security into something that doesn't work for them, they're going to just find a way to mitigate the security. And then they're really going to open themselves up for real problems. Mark, did you want to touch on this as well?
Yeah, so from a security perspective, Mike hit the nail on the head. Virtual machines are going to allow you to be more stricter in the boundaries that you create with them, because you can encompass the entire operating system and you're still sharing the resource pool of the host system. So, but from a security perspective, the tools are also more mature when it comes to virtual machines. So that's going to allow us to encapsulate them a little bit more and segment them. The nice thing about the containers themselves, though, is going to be if you require scale, then it might be worthwhile to take that little hit in the security aspects when it comes to the actual segmentation piece, because containers are still going to be accessing the kernel space of the operating system. So from that perspective, that would be one attack surface that you would not necessarily have with virtual machines. But again, it's always going to depend on, if you're looking for scale, containers might be a trade-off you can go with. Yep. If you're looking for pure security, and if you're looking for a domain or a platform in a sense that's going to allow you to have tools available when it comes to security and the distribution of different resources, virtual machines is going to be a lot more of a mature platform that you want to go towards. Okay. And the next question is from Willie. He's wondering, will there be some type of certificate of completion that will be issued at the end of the boot camp?
So, Willie, you'll be able to take the exam, pass the exam, assuming you follow our instructions, which will be a good certificate. Now, here's the thing. How do I know that you attended all day, and every minute of the boot camp? I can't. So there's no way that we could actually give a certificate because we can't verify you. Now, if you were in our training programs where I can know exactly when you signed in, when you signed out, did you turn your homework assignment? Absolutely, that's a different situation, but I have no means to know that you've actually completed the program, and I hope you understand that. But I will tell you this. All of us are all excited about the certificates we have. And after being a hiring manager and interviewing thousands of people, hiring managers, tech leaders, I asked them, do you care about certificates? And you know what they all say? I don't care about degrees, Mike. I don't care certificates. I care if the person can do the job. If the person has the skills, if they have the requisite knowledge, do they have the right attitude? Are they willing to go above and beyond? Are they a team player? Are they energetic, enthusiastic, and passionate about the work? So focus on being great. Don't worry about the certificates, and be so good that they can't not hire you, they can't not promote you, and get the 2 or 3 certificates that matter, and actually go through the certification process and show others how good you are, and then get those interviews and wow them.
Question from Cloudy. The control plane, is it Kubernetes and the runtime is Docker?
Cloudy, at one point it was always that way, but Kubernetes also has its own type of worker data plane that it can use as well. But yes, for a long time, Kubernetes was the control plane and the runtime was Docker. Absolutely.
All right, let's take a look. Another question is from Lisa. She's wondering, is machine learning basically a core of the CCSP?
Larissa, absolutely not. We spent 15 minutes on it. If something was the core of it, data is a big core. We may spend 5 hours on data. So the more time we spend on it, the more it'll make it obvious that it's the core. But great question, Larissa.
Well, let's take a look at the next question. And this one is from Sei. It says, when talking about containers and virtual machines, where do namespaces stand? So say in particular, when you're discussing namespaces, that's going to be more concept when it comes to containers compared to virtual machines, because the containers are going to be sharing the operating system kernel of the system itself. So in that case, there's going to be additional logical structures that you're going to have to actually set up to make that work. One of them particular being that you're going to need a virtual router to make it work. The way the IP address assignment is going to be a little bit different as well. So in that case, though, namespaces will be associated with containers Virtual machines, think of them as logical, complete entities of an operating system that you would be running, generally speaking, on your laptop or let's say on your personal computer. So one is going to be a lot more lighter weight compared to the other one. All right. And we have a question from Caleb. How does the container runtime module make the connection to the individual container? Does it copy the operating system or does it virtualize it? So Caleb, when it comes to the specifics, you will not need to know them necessarily for the CCSP. But when it comes to the actual container and how that's going to be centralized, that's going to be done on the back end through a form of virtualization. So from that perspective, since you won't have to deal with the actual implementation piece of containers and its additional modules, I would suggest that if you do want to know it, do a Google search on it, and that would assist you in understanding more of the intricacies from that perspective. And we have a question from Chris Blackwell. He's wondering, when securing IoT devices, would you recommend some form of endpoint security or I'm assuming that's software, the SW, I'm assuming, software maybe? If you can let us know in the chat if that's what you mean, Chris. Besides of that, let me explain. The problem that we'll have with the Internet of Things devices is that generally speaking, we can't really install anything on them. They're going to be more closed systems. It is because of that also that it makes it very difficult to secure them. That's why we generally look for opportunities to do some form of fingerprinting, which what is that going to enable us to do is figure out what is the underlying, almost like an operating system that's running on these different devices. So for example, let's say you have a refrigerator and that refrigerator can connect to the internet. So one of the aspects in security that we would do is we would create isolation, we would create segmentation on network, because since we can't directly install anything on the IoT device, we have no ability to actually install some type of endpoint detection and response system. If you want to think of something like a CloudStrike or something like that, we can't install it directly. But as the IoT device communicates to our network devices, let's say it's a firewall that we have. So we're going to take something like Zero Trust out of the equation, but let's say we have a firewall. As it fingerprints, what it might find out is that the operating system or some type of service or daemon that's running in the refrigerator is, let's say, Apache. And then it would have a code version associated with that. Now, we can do something with that. We can actually take that and include that in our policies when it comes to either firewall or if we're running some kind of trust engine. And then against those, we can create policies in not just isolation, but also what are they actually allowed to communicate to. So it's going to be a multifaceted approach to security with IoTs. All right, let's take a look at the next question. And it is from Daniel. He's wondering, number one, compliance requirements. What are the key compliance requirements focused on in the CCSP training? And how should professionals apply these to real-world cloud security?
So we're going to cover that in this program. So we're going to dedicate, many hours to it. So I want to cover that when we actually get that into that part in the program so we can address the questions that are related to the content.
Yeah.
Because we will.
Definitely. So next question is from Nigel. Have you encountered any version control frameworks or approaches that are typically used? I've never dealt with version control, but I give you a very simple example. GitHub is a platform that has integrated version controls when it comes to code bases or pretty much any documents that can use. Internally, depending on the security measures that you require, these are going to be proprietary softwares. Either they're going to be coded from the ground up, or they're going to be basically purchased or rented from a vendor. And then they're going to be locked and key, basically air gap from any outside systems. And Caleb, it says, why do container operating systems crash when the parent operating system crashes?
Okay. Let me cover this one. So Caleb, I want you to think about this. The containers themselves are pulling from the operating system. So if the operating system is dysfunctional, then everything on it. So imagine having a server in a house, and the house catches on fire. Obviously, the application running on the server will stop as soon as the server melts. Well, that's really what you're dealing with in an operating system crash. Think of it as a fire inside of the server, and then anything that's running in that fire just dies along with the fire because it burns it up. Hope that helps.
All right. And from Daniel, he's wondering regarding the shared responsibility model. Can you explain the shared responsibility model in cloud security? And how does the CCSP training prepare practitioners to navigate this effectively?
So I'll address that quickly, and then I'm going to refer you back to the shared security model that we discussed yesterday. So all the shared security model is that you are responsible for whatever you have running in the cloud provider's infrastructure, and they are responsible for managing the underlying infrastructure. So they manage their routers, they manage their switches, they manage their physical firewalls, they manage their physical load balancers, they manage their physical storage area network, they keep them patched and secure, and their routing secure. You put a virtual machine there, you have to secure your virtual machine. You have to determine whether you're going to use a security group, what kind of endpoint protection you're going to put on that PC, what kind of anti-malware, what kind of host-based IDS, IPS, what kind of host-based firewall system, what packages you're removing from that operating system, the authentication systems you're going to use in that, whatever encryption you want from point A to point B. So they're responsible for their stuff, and you're responsible for your stuff. That's the whole shared security model.
All right. Well, Mike, I would say let's get back to the content. And then what we'll do is in about 20 minutes, again, or 30 minutes, we'll tackle some more questions that everybody has.
Yes. And I can answer Yasel's question, do I commonly see Kubernetes running in a data center? Absolutely.
Mm-hmm.
And I commonly see big enterprises running an IBM OpenShift Kubernetes cluster across cloud providers, because that way if one cloud goes down, it doesn't matter. But yeah, lots of organizations run their Kubernetes control plane in their data center or across multiple clouds at the same time. And anything else? So
it says from Kennedy, yesterday I asked if there were regulatory framework and policies for cloud security architectures.
So we'll cover a lot more legal and compliance later, but it's not that there's going to be a legal requirement for a certain type of policy. There are frameworks that are out there, Zero Trust, NIST, that are suggestions on how you might approach something. Now, how you take that, interpret it, and then do it, that's going to be up to you, because they're not going to tell you what to do, because they're frameworks, which means you have to map to your actual needs. There are also laws like PCI, DSS, HIPAA for healthcare, and if a company is not compliant with those laws, they can be fined. I can tell you right now, there's not enough in the CCIE security, CISSP, CCSP that are going to be sufficient to truly familiarize yourself with those laws. So when it comes to the real high-end governance and requirements, you're going to be speaking with attorneys that specialize in this. But we will cover enough that you need to know to be able to do your job. But I've never been in an architecture where when it came to heavy compliance issues, we didn't use lawyers. And neither will you. So we'll get you what you need to when we cover those. But that's what you need to think about. I need to know you're awake and alert and oriented and having a good time. So give me a hashtag CCSP. That way I know you're awake, alert, and oriented. So we will go through that. I also want to remind everybody that we have a completely free book that our team wrote to go along with these classes. Goes from top to bottom. That way you've got something that goes along with these videos when you come back, and it's some key study resources. Please make sure you get it. Please join us on Thursday on how to get your first cloud architect job. We'll go over the role, we'll go over what we do, all the fun about the architect job, all the skills you actually need versus what people think they need. And then we'll answer any questions you have for upwards of, say, 90 minutes. And it's all free and it's on Zoom. So join us. And in many of our other videos, if you check in the videos, there'll be free resources to help you pass an interview, for example, or questions for your cloud architect interview or your AI architect interview or career preparation materials. They're all free, so go check out some other videos of ours when this is done. So now I'm going to briefly talk about quantum computing, very briefly, because, they only touch some of these things. And Quantum computing is a new form of technology, a new type of theoretical research in computer science that's basically replacing binary bits with qubits. Potentially, if the world goes down the quantum computing path, it could revolutionize the way we do things. Quantum computers can be so powerful that they can render many of our current cryptography techniques irrelevant, because they can crack and break these algorithms fairly quickly. Now, of course, the alternative is we do GPU computing, and it looks like this is where the real supercomputers are being built right now. But kind of keep that in the back of your mind. For the most part, quantum computing is mostly research and theoretical physics. Some big technology companies are experimenting here as well. For right now, there's very minimal impact on everyday computing. Now, let's talk about edge computing very quickly. Edge computing is really about making the computing closer to the user. So I'll draw it out for you if you all want, but I want to explain it first. In a traditional environment, let's say I'm sitting in a campus, and I've got 10,000 people that exist in this campus, and the data centers on this campus. You know what kind of performance we have? Incredible performance, because all our users and our entire network is close to each other. So there's almost no latency for anything. It's beautiful. Now all of a sudden I go to the cloud provider. The cloud provider is 1,500 miles from me. And now I've got latency when accessing the systems on the cloud, which may or may not be problematic. It depends on the business application we're actually running. In most cases, it doesn't matter. Sometimes it does. That's why our architects need to consider these things. But what if on the way to the cloud provider, there was another data center that was at the edge of the network that, say, was close to me? Well, then I could connect to that data center faster than the actual cloud provider, which might be 1,500 miles away and have normal or low latency, almost as good as I actually had in my data center. And that's why you'll hear about various things like local zones in AWS that could be used for that purpose. The edge computing could also be used for this. Imagine you've got a self-driving car, okay? And the car is an IoT device, an Internet of Things device. And it's getting its information from the IP network that's actually coming from its 5G mobile phone signal that it's receiving. Now, here's the way it happens. The car's got a 5G mobile signal. It hits a tower. The tower is backhauled to a data center somewhere. And immediately where that data center is, the computing is put in there. Now, if you think about that, the server that might be controlling the self-driving cars, or potentially involved in the self-driving cars, is closer to the car. That means reduced latency. That means faster braking. It means a lot of other additional safety things. So when we see Internet of Things devices, if where they connect to the network, we can actually put the compute there, we've totally reduced we've incredibly improved the experience. So let's look at what this actually looks like from an architecture perspective and the common use cases of this. So imagine you have a IoT device here. And the IoT device connects to the IP network here. Maybe it's Wi-Fi. So let's say this is an access point. Let's make it 5G. So 5G. So the device has got a 5G, network access device in it. Over here, by comparison, here's going to be the data center where your 5G network is. And here's the tower. So this 5G enabled device is basically going to reach the tower. The tower itself is going to have cables that are going to be connected to the 5G data center. So let's say this could be a Verizon data center or an AT&T data center. It doesn't matter. I'm going to call it 5G data center. And instead of the data center just having 5G stuff, they're also going to have switches and routers, and they're also going to have servers plugged into their network. server plugged into the switch. By switch, it'll probably be a layer 3 switch, but that's okay. So you can see your 5G device is going to connect to a local data center where the 5G systems are. And why is this important? Because going from here to the actual cloud provider itself might actually take too long, and we might want to reduce the latency. So we do the processing at the edge data center closer to then the cloud. So when you hear edge computing, you can think about things like that. It's about the reduction of latency across the network. So cloud computing's far, which means high latency. So using a closer data center typically makes things better. We're basically putting servers closer to the user where users would typically attach to the network. Another thing they bring up in this exam is something called fog computing. And with fog computing, we're placing gateway devices in the field, close to the user to collect data and correlate data. And it performs the processing, at remote locations before sending the data to the cloud. So in fog computing, it's not that much different. In this same environment, we've got our servers doing the data processing, and then they're sending the processed data back to the cloud. So a lot of these things are going to be very similar, but that would be your typical fog computing. Servers process the data and then send it to the cloud. So it's doing this because the processing reduces the latency, and that's the point. Now let's talk about confidential computing. So some organizations have real security needs, where a breach of information could mean the damage of billions of dollars, lives lost, and all kinds of things. They have serious security. So confidential computing is based towards these types of needs. The point here is to extend extreme security through every part of the computing process. So let's talk about the normal client-server model. Client wants something from a server. The server accesses the data from whatever the storage is, which is block storage, which is somewhere else, and the server processes the data. So that's a lot of different places, right? So let's think about traditionally how we deal with it. Traditionally, we encrypt the storage on that block storage drive, which is somewhere else in the data center. And we might use IPsec connection over the network connection or TLS encryption along the way for the data in motion as well. We could do something like that as well. But what about the data in use? The data that's in our server? The data that's sitting on the DRAM of that server? That's not protected. Now, in most environments, it doesn't matter. But what can we do here? With confidential computing, we're actually going to be protecting the data that's actually in use, that's actually in the RAM. And what it uses a trusted execution environment. And what we're dealing with here is making sure that no process outside that specific memory space can actually view any of the data within that trusted execution environment. So we've got confidential environments. The server itself is being locked down from the DRAM being accessed by any other part of the server. So that is confidential computing. Now we're going to start getting real geeky about data. I apologize already. Some of this will get geeky. Some of it will get a little on the challenging side, but it's an important topic. There's lots of data breaches in today's world, and it's a big part of the exam. So thank you for bearing with me. Give me a hashtag data so I know you are awake. So let's talk about data in the modern world. Data is an asset. It's something that benefits the business if they know how to use the data. Data can be used to make better decisions. So you can make mistakes, or potentially you've got enough information to make a better decision and make less mistakes. Imagine a business which is just all about taking risks and trying to mitigate those risks as much as possible. The better data you have, the better decisions you have, the less risks. So In today's world, data matters for those machine learning things we talked about and building predictive analytics and things like that. But let's also talk about data in the context of AI. You want AI to write code for you, you better train it on good data, because if you train it on bad data, it's going to give you bad code. You want AI to write a document for you based upon all your internal information and trusted information? You train it the right way on good data. You feed your AI model with bad data, and guess what you're going to get? Bad AI decisions, and the AI is going to go a little cuckoo and wacky on you. And we don't want cuckoo and wacky AI. So, kind of think of it that way. So we need clean and accurate data. So when it comes to data, there's terms we have, and there's also legal terms we'll get involved with along the way, especially as it pertains to Europe, to people working with data. But first thing we need to talk about is data ownership. Somebody owns that data. It's typically the CEO or the creator of the data, what have you, but somebody owns that data. That person needs to assign responsibilities to the data. So who's allowed to handle the data? And we have to make sure that whoever handles the data does so in a responsible way that uses proper data handling procedures. And when we think about data ownership, we're dealing with legal ownership. There's responsibilities of owning the data. And the roles of data and data ownership can be specified by laws, regulations, or contracts. There will be a point where we talk about the EU's data terms that organizations have to have, but data matters, and the more sensitive the data is, the more damage it can do. So let's talk about common roles in data ownership, and this is legally required in parts of the world and is part of the exam, so bear with me. So the data owner is the organization that creates or collects the data. There's usually a specific data owner inside of that organization, often a department head or a business unit manager. In the cloud customer is typically the data owner. So you own whatever data you put in the cloud, and you are responsible for it and whatever happens to it. So often in international treaties, you see the data owner referred to as the data controller. So, I don't know, football, soccer, two words for the exact same thing. I didn't make it up. So another role, especially which you'll hear in Europe, is something called a data custodian. And a data custodian is a person or entity that's going to be responsible for the daily maintenance and administration of the data sets. So this person, the data custodian, someone that's working with the data or maintaining the data, they must apply security controls that are directed by the data owner. So if I own the data and Mark is my data custodian, which he's not, Mark is part of my C-suite, he's my CTO, but pretending he was my data custodian, he'd be responsible for that data. And sometimes, the data custodian could be a database administrator inside of a company. If they're working with that data and they have to administer that data for the most part on a daily basis. So, that's typically what you're talking about when you hear the term data custodian. So the next type of data role, and these are not my terms, I promise you, is a data steward. And a data steward ensures the data's context and its meanings and to make sure they're understood. So the data steward is making sure that business is making proper use of the data. So another role we need to talk about in data ownership is something called a data processor. And that's any person or an organization that's going to manipulate, store, or move data on behalf of the data owner. So a data processor may move data from one server to another. So a data processor might be copying data, printing data, physically destroying the data, either via some form of e-shredding or an e-shredding with the destruction of drives, and, for example, or even utilizing data. In an international law, in many cases, the cloud provider, they're considered a data processor. So when we think about key points that are associated with data ownership and data custody, data processors don't always have a direct relationship with the data owner. I can specify, for example, a third party that's part of my data processing team. A data owner, by comparison, is legally responsible for all the data. So if the CEO is the data owner of a business and that business has a big data breach, that CEO could potentially be responsible, or at least the company could. So hope that makes sense. And here's the worst part of it. If you are the data owner and you put your data in a cloud provider and the cloud provider is compromised, the data owner can still be legally responsible. So now you're responsible for your data and your mistakes in addition to the mistakes of the cloud provider. So the question that business owner has to have is, do I trust the cloud provider or do I trust myself more? And every business will face a different decision. Now we have to a little bit about ownership and custody. This is specific to certain data under certain circumstances. So cloud providers are going to own the underlying infrastructure. The routers, the switches, the servers, the storage area networks, what have you. But they're not necessarily responsible for the data because the data owner is the cloud customer. When we start thinking about any kind of shared security module, what does that mean? It means you're responsible for your data and they're responsible for their underlying systems. So for example, what happened when a cloud provider's cloud native database was hacked? That database was hacked, the cloud provider's database was hacked, and their customers' information was also hacked because the cloud provider got hacked. So, and that doesn't mean that if they had a data center, they wouldn't get hacked either, because there's always risks. But just think about all of this, because every business will be weighing these decisions as they think about their cybersecurity architecture. So the data owner is typically considered to be the best person to understand the organization's data usage. Because if you run the business, you should be the most responsible person for the use of data. It's responsible for categorizing data. And businesses may have a huge number of categories and types of data. And when an organization categorizes its data, they can make it in some clearly defined types, or they can use some arbitrarily designed things. Mike's data, Nick's data, Maria's data, Aguilo's data, Spiro's data. It could be that. Or it could be secret, top secret, what have you. So, there's lots of ways organizations can classify data. Now, there's lots of reasons organizations should be considering classifying data. One of the reasons would be for security to know the level to secure their data, and that would be a good reason. Another reason could be regulatory requirements. So, there's different regulations that govern different business activities. So, healthcare's got their own regulations, HIPAA. Europe typically has theirs, GDPR. PCI DSS responsible for payment cards, SOX compliance related to publicly traded firms. There's always going to be something. And we may also want to categorize the data based upon business function. So this is marketing's department. This is the operations budget. This is the billing budget. So we could do it that way as well. So sometimes organizations categorize data by functional units or departments. I always think of GE, at least the old GE, where they were making medical devices, and they were making rocket engines, and then they were making trains, and they were making medical equipment. They were impressive. They had everything. They were making appliances in this division. So each one of those divisions, realistically speaking, could have, were different business units, and those business units could have separated their data by functional unit. Other ways organizations label or classify their data is based upon project. All data related to one project is here. Data related to the next project is here, and that's another way that it can categorize it. But here's the thing. If you're going to categorize something, and this is a mistake that in my own life I'm guilty of. You know, I don't necessarily use the same categorization structure for everything, right, in my home. You know, some things I just label C for Cindy and L for Lisa for my wife, and some things are labeled M for me. I've got some labels for friends that come over. I mean, it's not exactly a formal system, but, you know, that's a categorization that works for a house. Now think about an organization like Microsoft with 250,000 people. They need a systemic and a consistent and a highly structured means to store and categorize their data, because otherwise it'll go haywire. So think about that. As long as we have a uniform way that we adopt it and a means to enforce the standards that we have, we should be good to go. Now, how we classify data is going to be the responsibility of the data owner. So the person that creates the data, that's responsible for the data, needs to be the person that classifies the data. Now, here's one way that in many cases data should be classified. But again, it's going to be dependent upon the business use case. Sensitivity. That is a great way to determine what level of damage the data could do to you, to determine what level of data protection you need. So we could have unsensitive data that's unclassified and various forms of classified data that's sensitive data. We could also classify our data based upon jurisdictions. So if we've got privacy laws in different countries, we could separate and classify our data that way to make sure we're in compliance with laws. And should we be audited, and when we're audited, we could easily prove it. We could classify our data based upon criticality. So how important is this data for the business? And how do we figure that one out from the business impact analysis? So I hope it's starting to get clear to everyone. You know, in that cloud architecture or that cloud security architecture or security architecture world, each one of the ways that we determine how we label our data will determine how that organization can use that data and protect that data and deal with legal and regulations as well. So just that can take a bit of time to actually figure out. So let's talk about how organizations can classify things, organizational policies related to classifying data. So we have to identify classification levels if they exist. And then we have to assign responsibilities and define roles of our data team. Who's allowed to classify it? So we're going to need that from a data governance perspective, and any kind of ways we start using automated tools, we need it to follow a consistent data classification policy, which should follow our organization's classification levels. Something else we may be doing is something called data mapping. And what this really is going to make sure the data that's shared between two different organizations, what's being shared is appropriate, it's trusted, it's normalized, and it's translated for mutual understanding. So if I send another organization data that's not trusted, I hope you realize that's not a good situation. So think about that for a second. So I have to determine who's going to be involved, especially when I'm dealing with recognizing sensitive data, protecting sensitive data across two different organizations. So if I'm not methodical about this, if I don't plan this well, we're going to be exposing classified data with a real undue risk of threats coming out, and that's not what we want. So we have to be methodical about how we sensitize, we recognize, and classify it. And when it comes to data mapping, what we're going to do, there's a couple ways we can do it. We can do it manually. We can do it in an automated fashion. There's technology that can help us with the data lifecycle, that can help us with data creation, data use, especially when we have the data and it's modified or things are going along the way. So there's lots of approaches we can use. We can use a hybrid between automated and manual. But when we're mapping things, here's the things you need to consider. We need to make sure that we've got whatever data classifications we have along the way when it's mapped to something else on the provider side. we need to make sure that any oversight or security controls we have are going to be mapped over when we share any of that information, or we don't, with another user. So think about that. So we also want to talk about data labeling. So we, at some point, we want to create data labels after categorizing our data and classifying it. So maybe the label will include information about who at the office is the data owner, but not necessarily an individual name. Indicate the role or the office. And again, when it comes to labeling things, we have to use labels that are going to be ensuring understandable and consistent behavior. We might want to have a printed hard copy label, potentially if there's like a disk or something that's being shipped along the way, or a DVD or a USB drive or a physical hard drive. We may want to embed file names or attach metadata to our data. And if you think about object storage, which we widely use in cloud computing, one of the reasons we love it is that metadata, or the data about the data. So if we're gonna label our data, and again, I'm sorry, this is rough stuff to go through. It's not super fun, like designing demilitarized zones, for example, for your web applications. But when we make these labels, maybe we want to label when the data was created. We might want to also add to the label when the data should be disposed of or destroyed. We might want to say top secret, secret, unclassified, or something like that. We may want to label it and say this data can be accessed by Cindy the cat, but no one else, potentially. So those are the kind of things we might want to add to the labels. And the point of this is organizations are going to have petabytes of data. They're going to have so much data. And as we use more and more data, we have to be careful where the data comes and how it's categorized and what access people have access to. So this is going to be a part of data management, data labeling, throughout our data lifecycle. And this also helps us with data loss prevention systems, which are going to determine how keep us and prevent us from losing data that we don't want. We should be using these types of data labels, these types of data classification, these types of data categorization all the time. All the time, yes. And Amos, I'm so happy to see you here. Yes, I did say Cindy the cat. I have a cat named Cindy, so I use her as an example all the time. So the next thing we have to think about when we have data is how's the data moving? We're going to be talking about data flow. How is the data that it flows through the system? And this includes things like data sources, the data controls that exist, and you often do this in sort of an architectural diagram that's going to show the way the data is moving. So when we start looking at data before we plan things, we have to think about things. So we have to understand the data we have. So we have to create an inventory of the data. Now, how do we figure out the kind of data an organization has? And I gotta tell you, there are many organizations that want to heavily invest in AI, and their data is so bad that it's going to take time to clean, to prep the collective data long before they can ever even think about being successful with AI. And there's also many organizations that have been keeping meticulous data because they've been planning some of these things. So we have to accurately somehow inventory the data that the organization actually has. So that inventory could be an electronic discovery, data mining. There's going to be a process to kind of figure out what that organization has. And that may take some people coming in, some people that may have clearance if necessary, some people that can sign a non-disclosure agreement, that meaning they won't disclose any information about it. And there's people that are experts at this. So we could use database-based discovery. Sometimes when we walk into an organization, we are really lucky and they've got good data labels. And we can look and see what they have and say, yes, we've got this data label. It's good, it's clear, and it's going to help us figure it out. Sometimes you get lucky. Then again, in my old internal medicine days, every once in a while you get a nurse practitioner or a physician assistant or a physician that's your patient, and they say, I have this. And you're like, well, let me check for myself. And then it says, you're right. Well, sometimes you walk to a customer that's done it all correctly. So we can think about, we can use utilities to also help us. There's tools that can help to some degree as well, but they'll give us a faster response to a specific mandate. Maybe we've got a court order, a regulatory demand, and we need to accurately do something fairly quickly. So we could use utilities as well to help us with that. Another way we can discover the data is metadata based. So one of the great things about the cloud is people place a lot of information in object storage. Object storage has metadata or data about the data, which makes it very easy to find data from that. Often easier than if that data was sitting in block storage or, say, file storage, although it could be mined from that too. But it's often easier. So organizations that have invested heavily in object storage in their data centers have an advantage here. Organizations that have leveraged cloud providers, object storage, for example, AWS S3, Azure Blob, Google Cloud Storage, all the same kind of technology, have an advantage because they've got some good metadata typically about their data. And we can scan metadata for functionality, maybe for specific terms to collect matching patterns, but that search is only going to be as good as the metadata actually is. Let's talk about some content-based discovery. And that's going to be used when we don't have labels and we don't have metadata. So in this particular environment, it's going to involve delving into the data sets. So maybe we're doing basic term searches. Maybe we've got some sophisticated pattern matching techniques to identify specific kinds of data. We're going to get into the structured, semi-structured, unstructured data next. Chris or Mark, how long has it been since we last answered questions? I know some of this data stuff is a little bit rough, so I want to make sure we take the time.
I had about 15 minutes, a little bit more than 15 minutes, but we can definitely go ahead and take a couple of questions that were brought up. So if we want to feed the first one, I believe that one came from Chris Blackwell, but let's take a look and see what pops up. All right. So the question from Chris Blackwell is, Mike, who is ultimately responsible for the data sovereignty? If we are the architect, would it be our responsibility to or the client? And Mike, do you mind if I add something to this first a little bit?
Why don't you take care of this first?
Yeah, we'll have an entire section when it comes to any of the legals, the governance, the compliances, and so forth to discuss. But just to give you a brief answer to your question, Chris, it's always going to be a shared model. Ultimately, though, the person that owns the data, they're number one responsible for that data. Now, as the architect, your responsibility is going to come in as being a trusted advisor, especially when it comes to recommending particular compliances based on different lawyers you're going to bring in, people that know local laws, that know national laws, and those are basically there's going to be a form of collaboration between those parties. So that's generally how that looks too. So again, client, ultimately, you're going to be the end-to-end designer. You're going to make propositions, you make recommendations in conjunction with the legal team so that you're going to be in compliance. All right, let's take a look at the next question. And this is from Nareen. He's wondering, what is the relevance of shared responsibility models when we are talking data communication through orbiting satellites? Wow. Okay. So that is a good question, Nareen. Now, there's going to be some of that aspects when it comes to the CCSP, but what you need to understand here, you need to start breaking down who owns what. For example, if let's say we're going to consider the actual infrastructure. Part of that responsibility for the infrastructure, so you think about launching pads, you're going to think about things such as managing the position where the satellites are going to be, if they're going to be low or medium or high. Those are going to be part of the satellite service provider's responsibility. Same with the ground stations, same with the signal transmissions. Any regulatory or compliance, that's also going to be their responsibility. That's not something you're going to worry about. But going back to this idea of data that Mike was already talking about, the data is your responsibility, meaning you will have to make sure that the data is secured, meaning in transit, we want to use encryption. depending on where the data eventually is going to go to, if that's going to be a cloud location or otherwise an on-premise data center or some type of private or hybrid connections that we have between the different data center, you're still going to be responsible for the eventual endpoint security as well as the application-based security. And then when it comes to compliance, just to piggyback on what was it at? So I get the name right. Chris also mentioned data is always going to be your responsibility and the architect's responsibility in regards to the recommendation that you get there. And then anything that eventually plugs into the actual cloud service providers, that's going to depend on how the actual infrastructure and everything is going to be set up with the connections. Let's say using like a edge computing zone or something like that. That's going to be then part of the cloud service provider. So nothing that you're going to have to go too crazy into the dev, but you're going to do the same thing. You're going to break down the concepts, infrastructure. If that's going to be outsourced, that's going to be the actual satellite service provider, and then you go from there. Yeah. And from Scooby, he is wondering, must you be eligible for security clearance to conduct this role within the capacity of your offering objective?
It depends what your offering is. So I've spent my career working for the world's largest banks because they had the budget to pay for anything, which was really great. I could always put and for the world's biggest banks, if they could shave a nanosecond off of a trading system, it was a competitive advantage. So it was all the biggest budget, best technology, coolest projects in the world. So I mostly work there. Banks don't need security clearance. They also have the biggest budgets for you. At the same time, I spent the rest of my career in healthcare designing healthcare systems that would be operational and secure. Guess what? Again, that's dependent upon life, so I've worked there. Now, if I was going to work for the U.S. government, I would need to get security clearance. The private sector, you typically don't need security clearance, and you typically earn far more in the private sector, but it's up to you and where you really want to work and what your ultimate goals are. But if you're going to go work on a military base, you're going to need security clearance. You're going to go work for a bank, you probably don't need it. So in most cases, you don't need it. But I will tell you this. For big security roles, regardless of whether you are in a bank or U.S. government, they will background check you, they will fingerprint you, and they'll go through a whole bunch of checks on you before they let you touch these systems. But you don't necessarily need security clearance.
All right, and I believe that was all for our questions so far. Everybody,
all right.
Whatever questions you might have for us, be sure to log them, put them in the chat, write them down if we're having in the presentation. Aside from that, I hope everybody made sure that they grab the study guide that we had down in the description on the LinkedIn post so that you can follow along with the actual session, especially when it comes to data in general, especially its hygiene, categorization, as well as its classification. All right, I'll bring it back to you, Mike.
All right, well, let's get back to our CCSP training. I always love stopping to answer questions along the way. I'm trying to make this data as interesting as I can for you. If we were talking BGP, now that I know how to make fun, but regarding this. So let me address this one question because it keeps popping up. It's regarding the CISSP, the CCSP. Go take the exam. I don't care if you've worked or not worked, just go pass the exam. When you pass the exam, it's the same exam as anybody else passes. You add it to your actual resume. You will be technically an ISC squared associate, but you show that hiring manager you passed the entire CISSP or CCSP, the hiring manager doesn't care. Because the hiring manager doesn't care about your piece of paper in the first place. They care about your skill. And if you're able to pass that exam, I use the CISSP, this kind of thing, as my fundamentals training for cloud security. Because it opens up these doors. A course like this, a course like the CISP, it shows you exactly how big the security world is. It gives you enough to realize how big it is, and then you can pick a career that could be in any one of these components of it and dive deep for the next 20 years. So there's that. So pass it, put it on your resume as an ISC-associate, and then if you have a hiring manager that says, what's an ISP associate, you got the best thing. Mark's going to be the hiring manager. I'm going to be the newbie with no tech experience. Mark, ask me what's this weird CISSP associate?
Mike, thank you for being here today. Could you explain to me what this CCSP associate is that I see on your resume?
Absolutely, Mark. Mark, the reason I took the CCSP is it's considered one of the hardest exams in cybersecurity, and I thought if I was going to be great, I'd have to take the really hard exams. They, for some reason, believe the exam is so hard that you need 5 years of experience to pass it. So even though I passed the same exam as everyone else, they have to keep me as an associate for the next 5 years. My perspective was this. I should start my career with the things that most people never get in their career, and that would be a platform where I can be an incredible cybersecurity architect.
Perfect.
You
Now,
happy, Mark? Do I seem more motivated? Yeah, but do I seem like a motivated guy to you?
Yeah. And just so everybody
Someone
realize,
that cares
the fact that
about my
he's
career
willing
development?
to do what many people are not already tells me that he's different. So now what I would do from that perspective, I might ask 1 or 2 more questions. And I guarantee you, I'm going to see the competence there. And then it doesn't matter the associate status anymore, because that's all it's going to be. Just a simple status. It has nothing to do with your knowledge, your ability, your skill set, and your competency.
Yeah. And having experience has nothing to do with your ability to get hired if you can answer yourself properly. Nothing. And I can show you lots and lots and lots of experience.
Question from Daniel. He's wondering, in regards to encryption standards, what are the encryption standards taught in the CCSP training, and how are they applied to protect sensitive data in the cloud?
Well, Daniel, good news. We're going to have many hours of discussions on that, and they're coming up soon. So when we cover it, it'll be covered for you. And let's get to chat. If you're working on a budget, should you go for CISSP instead? If you only had to do one, I'd probably do the CISSP. It all depends on your career goals, though. And I don't know exactly what your career goals are. Each certification does things different. For example, the CEH Master and OSCP are very effective certifications for a penetration tester or an ethical hacker. The CISSP and CCSP are quite good for a cloud security architect or a security architect. The CCIE security is really great for a security engineer that's going to be configuring firewalls and IDS, IPS systems and network security. And it provides a network security focus. So that's the real question. Where do you want to go? So let's get back to the let's actually get back to the context. And yes, Daniel, all the questions you're asking are the things we're going to be covering over the next 2 weeks. So unfortunately, I can't go spend 3 hours for them in the middle of a topic we're going to do. But if you stick around, you'll get access to all those answers. All right, let me know you're awake. Give me a hashtag CCSP. So now let's talk about semi-structured, structured, and unstructured data for a little bit. So let's begin with structured data. If you think about a relational database, for the most part, rows, columns, that kind of thing, where your data is highly sorted via very meaningful and discrete data types, that's what we're talking about here. Relational database, structured data, data that's very structured. No. When you've got highly structured data, how easy is it to run an SQL type query on it and actually look for something? Very easy. So, very easy to find information. And that's why relational databases, for example, are the mainstays of transaction logs. They're very efficient at what they do. Now let's talk about unstructured data. So here's unstructured data. I have 3,000 photos of my cat Cindy. It's crazy. My wife and I probably have 50 photos of each other over the last being married for 30 years or 28 years. So I don't know, thousands of photos of the cat somehow. So there's that. That's unstructured data. I also have a bunch of Bob Marley, Ziggy Marley records that I bought that I turned into MP3s that sit on my computer. Again, that's unstructured data. So think about that. This kind of data isn't the easiest thing to try to mine through. AI tools can help us, but it's not the easiest kind of data to find out information. Then we have semi-structured data. So this is data, maybe it's got a tag or another element that can give us a field or a record or something. It's not really super structured, doesn't require the rigid structure of fully structured, and that's semi-structured data. Often, for example, we use semi-structured data with NoSQL databases like MongoDB, Apache Cassandra. Semi-structured data might be where you are in the middle of a movie that you're watching on Netflix, for example. That you're 5 minutes and 27 seconds into it, or something like that. So when we're dealing with data and data discovery, we may get involved into some regulatory challenges. There may be laws and regulations that will limit types of data discovery. So this can impact data storage, its data processing, and its data transfer. An example is going to be data sovereignty, which we'll talk about, which is where your data must stay in a certain place. Okay. If I need to keep my data in a certain country, and a cloud provider starts replicating their stuff across regions or to other countries, poof, I just violated my data sovereignty. So we'll talk more about that when the time comes as we go through the material. So we also want to think about data locations and where our data is coming from and the technical challenges. So if we've got structured data that's sitting in a relational database, this is easy. But we can pull it, right? Now, with the cloud, do we have ingress and egress feeds, pulling data in, pulling data out? It's all changing, but you gotta check that. So just keep that in the back of your mind. If you're going in and out of your data center, as long as you got availability and bandwidth, you don't have to pay for anything. But with the cloud providers, you're usually paying for data transfers. Unstructured data, free-form text, requires highly complex queries to get actual data. So remember, structured data, easy. Just run a structured query language query on a server that's sitting in a relational database, and poof, you got it. Semi-structured, not terrible because we've got some type of structure along the way. Unstructured data, more complex queries, or a lot more machine learning. So we have to think about data discovery, data location. So we have to understand where the data is actually at. Where is it stored? Is it in my brother Mike's house? Could be. Is it sitting in a data center? Is it sitting in my cloud provider's data center? Is it in Ohio? Is it in Palm Beach, Florida? Is it in Port St. Lucie, Florida? Is it in Miami? I don't know. Is it in Nepatamos, Greece? Where my family is. I don't know. But we can choose to where we put it, and we can obviously determine the security level of those locations, and we need to constantly think about it. So we have to consider data usage and data analysis methods as well. How are we going to get our data? What kind of analysis do we actually need to run on that data? So we have to design methods of discovery of data that's actually legal, technical, and organizational. What if, for example, I ran an AI analysis on a bunch of patients' medical records that actually had patient medical record personalized information, and somehow AI did something with that? I'd be breaking a whole bunch of laws. So that's why we need to understand what we're doing, how we're doing it, how we're discovering it, and make sure this process is quite good. If you're starting to figure out that you can build an entire career in data security, good. Just data is one form of security where you could spend a lifetime. You can whole careers in data loss prevention architects, people that just do data loss prevention strategies. So keep that, or careers that are built on that. versus careers like mine that were built on more network security and networking. But there's lots of different kinds of security that you need to understand. And we're teaching you the fundamentals here, but understand that each one of these fundamentals you could go down deep 10, 15,000 pages on and build careers on these. So when we're dealing with data analysis systems, now we've got more data, right? So we could be getting data feeds from existing data sets in an automated sort of way. It's one thing we need to think about. So how are we dealing with our data analytics, and how is the data coming in? And when we consider that, the data is coming in, how do we label it? How do we classify it? What other tests do we have to deal with for the newly generated data sets? And now at this point, now we need to start thinking about data analytics. So this is where we start getting into data mining. So I've got all this data. It's hard to figure out. Well, now the cloud providers have a lot of these big data frameworks that can detect our data, analyze our data, and actually, do something with the data. We can have, in some cases, we can mine our data and get relatively close to real-time analysis and recommendations. So if we've got a streaming data pipeline and that feeds into a machine learning system, we might be able to get recommendations in real time, depending upon how we built it, and then put some form of a visualization software out to that. So got the data coming in, AI is mining the data, AI is making recommendation engines, and it's presenting it to the decision makers, buy the stock, sell the stock kind of thing. Now, the whole point of mining all this data, collecting all this data, is business intelligence. I mean, having data for the sake of data doesn't help anybody, but if we're pulling this data and we can mine it and we can find it, can we find patterns in that data? I bet you can, not a human, but there's patterns in that data often that these AI systems can find. And we're going to be using recursive and iterative tools to really detect complex patterns in our data. And what can we do with that data? And these are one of the tools here. Now, AI is not going to do all the analysis, but imagine you've got a team of scientists that already are quantitative people doing analysis. AI can make a recommendation. They can now analyze that recommendation, get these recommendations faster. They can make better decisions very quickly. Okay, so with regards to data and data security, let's briefly talk about information rights management. So the whole point of rights management is to extend digital rights somewhere to protect the information in the document. So if I've got a document that I want to share with Mark, my chief technology officer, I might want to share it to Mark, but I may not want others to see it. So I can put out digital rights management that can determine that who's allowed to view the document, who can modify it, who can share it. And this gives organizations the ability to provide some specific controls in addition to their traditional access control mechanisms. The key here is to protect assets, usually at the file level. So when it comes to information rights management, let's talk a little bit about data rights. And basically data rights are which users are authorized to take actions on an asset. So Mark can copy and print and view and forward and even delete, but Sally cannot. So anytime we're dealing with anything, we should consider information rights management. Maybe we use it with email so that somebody can't forward a sensitive email. Maybe we use it with our communication tools, internal communication tools, to make sure messages can't be sent. There's always things that we can do. So if we're going to use information rights management, now we need a system to go manage that, right? So we have to provision these systems. Now imagine I come up with such inefficient rights management that my 225,000 employees now need an extra 8 hours a day to work because everything I made is so challenging. Well, now that business needs to hire 500,000 employees versus 250 to do the same amount of work. I don't know that many businesses that want to go that hard to get their security there. So the key is we have to find that balance between being as effective as needed and whatever percentage of use cases we can analyze, and still not obtrusive to the organizations and the people from being able to function. So often we can use this some type of a role in a group base. So at some point we'll talk about identity and access management and role-based access control, but I'm going to introduce the concept here. So I've got two options when it comes to determining who users are. So IAM again is who are you, or who do you claim to be? I claim to be Mike Gibbs, so it's verifying I'm Mike Gibbs. The next thing is what are you allowed to do? Well, I'm Mike Gibbs. I'm allowed to do whatever my wife and my cat tell me, which is, my authorization. What is my accounting? What are all the things that I've done that my wife and cat could go check and see what I've done? That's it. So there are two ways which companies can apply these type of rules for their employees. One is you could have one person literally go and say, Mike has these rights, Cindy has these rights, Mark has these rights, Alonzo has these rights, Nico has these rights, Aguilo has these rights, Avi has these rights. We could do this if we wanted, right? But now I got to literally go to every single user and do this. But what we could do instead is we could say, CTO team, that would be Mark and me, because I'm the data owner, and Mark and I could access this, and only Mark and I can access this. And then I could have the COO team, which would be Chris on the back end, my chief operating officer, and me working together. I could do a CMO team and add me and Alonzo, and I could create a group. So if I've got like 1,000 systems administrators, I would create a group systems administrators, apply the rules that all systems administrators need, and then add those people to the systems administrator group. Same thing with information rights management. If we have the ability to do it that says this group, this group, this group, it's going to be a lot easier to determine who can actually use these systems. I hope that makes sense. And that way we can give relatively granular permissions to a group and not have to do it for every other person, because it'll become a maintenance nightmare. So when provision these access, we have provision and access any information rights management tools. We have to think about the way these tools are designed and the way they're implemented. So there are file-based tools which we can use. And a lot of these tools typically encrypt files. And they use something called the license file to basically describe permissible actions for the user. So you got the system, it'll encrypt it to make sure nobody else can see it, and it'll determine how the user is allowed to use it, which is one of the things they do. Now, other ways we can deal with information rights management is certificates. We can identify various users and computers in our rights management systems. We can put a certificate on them, and the certificate could be used to validate the user or the computer. And we can basically create a license to the content. So I've got a certificate that proves Mark is Mark. Mark's got licensed access to the content because he is an allowed user, and Mark can use it. And if for some reason Mark does something scary, I can revoke his certificate immediately. Mark tries to log into the system and he won't be even allowed. So certificates always help with regards to scalability. So let's talk about a little bit about information rights management in the cloud. So many of the cloud providers have native information rights capabilities, which makes life a lot easier. They will encrypt your files, allowing access only to authorized users. There's licensing information available that can determine and support user rights. And typically speaking, this is going to require clients or web applications to support the decryption process and rights management. So let's talk with regards to general traits of information rights management tools. They're typically implemented by manufacturers, vendors, or content creators. For example, you may see them in music. You can't copy this music, can't copy this DVD or video, that kind of thing. But typically there's some kind of labeling in these tools that's with regards to data or metadata or some kind of way to basically help describe things. So kind of helps. So if there's lots of different techniques that are used in information rights management. An example might be Adobe Creative Cloud or Microsoft Office. There are rights management tools that are built into most of these things. So when we're dealing with information rights management, some things are a little more complicated in the cloud. So One is with regards to replication. Cloud providers replicate their data in various places, which is why AWS S3 or object storage, for example, is 99.99% available, which means it won't be it won't be up to 52 minutes per year. So there may be time you need to access your data, but you can't. But they say it's 11 nines durability, meaning 99.99999 to all the way to 9 places past the 99. Now that's because they replicate this data to so many other places that if something were to happen to your data, even if you can't access it now, they'll be able to restore your data. So how do you replicate data that you're not allowed to copy? It's one of the challenges with regards to rights management systems in the cloud. Because everything in the cloud is virtualized host instances, so to speak. Now, with regards to rights management in the cloud, we can also run into jurisdictional conflicts because basically the cloud extends access across boundaries. So we might have rights and property rights, intellectual property rights in U.S., but that may not extend overseas. So if our data is copied overseas, it may not be protected anymore. So we have to think about that in the context and the risk of cloud computing, the way cloud computing replicates data. So we also have to be careful that we don't run into any type of an agent or enterprise conflict. So for example, we may have local agents that sit on our servers right now, or our workstations that work perfectly. And now we stick them in the cloud environment and they don't run properly. So that's potentially a concern we need to deal with information rights management in the cloud. So there are times where let's talk about mapping your identity and access management along with information rights management together. So we want to make sure we have no access control conflicts. So we may have a content-specific access control list that's in the identity and access management system, but at the same time, we want the user to have access in it. Because our information rights management and our identity and access management rights management aren't synchronized. Now, generally, you run into this problem when you use outsourced IAM systems like cloud access security brokers, but where you have an API conflict where the systems aren't exchanging information the way they could. But not every application offers the same performance with every IRM tool. So think about that. Everything has to match along the way. So one thing that we need to think about with regards to essential functions of information rights management is it has to be persistent. I mean, it has to work regardless of the location, regardless of the data's duplication or usage. The protection in data rights management should be difficult to circumvent. If I say this is hard to do, but then if I put a protection on, but the protection's irrelevant, it's not going to serve me very well. So it should be hard to circumvent. The more you need to protect the data, the harder your data protections need to be to circumvent. I might need an encryption algorithm that's super severe for super private data. What if it took me 50 GPUs just to a week to generate the key for data that went across the thing? That's going to give me some degree of protection for longer than if it was something that could be done on 3% of a CPU. Kind of hope that kind of makes sense. So let's make sure that these information rights systems have to have dynamic policy control. So I need to be able to make it that Cindy the cat can access this today. And if Cindy the cat gets caught selling secrets to other cats in the community, I need to be able to revoke our assets immediately in our information rights. I need to be enabled to be able to enable in a good information rights management system an automatic expiration. So this data won't be able to be accessed after a certain point at a certain time. And of course, the protections cease as soon as that expires. So we might want to do this after a license were to expire, for example. In any case, if we've got any form of information rights management systems, it needs to be audited consistently. And because we need to enable comprehensive monitoring of content and access histories, we may want to make sure that we can add any replication restrictions. So maybe you can't copy it, you can't screen share it, you can't print it. If all of a sudden I need to be able to revoke rights, I can do it. Examples involve there's litigation situations when somebody needs to immediately pull someone's right, or copyright infringement environments. We have to be very concerned about these types of things. All right, so now we're going to talk about data control. So when we have organizations, they must control data throughout the data lifecycle. So from the time the data is created to the time the data is destroyed, the organization needs to have control of that data. So part of the data control and the data lifecycle policy will be policies on data retention, policies on archiving, policies on data deletion and how data will be deleted securely, and even legal holds. So let's talk about data retention periods. How long do we keep the data? Maybe it depends. It always depends. And that's why architecture is neither, you can't have a pre-made decision. It always depends. So maybe we need to keep a log for days. Maybe we need business data for years. Healthcare banking data, you need to maintain some of those records for 7 years in certain industry and cases. So regulatory environments can determine how long you hold the data. And if you're legally required to hold data that's 7 years old, there's architectural choices you can make to store that data in places that cost less, because you don't need access to it very quickly. So there's various ways, and we have to determine what we're going to do with the data, where we're going to put it, where we're going to store it. But at least from a data retention period, it could be very influenced by legal needs. And many types of data, it must adhere to regulatory guidance and contractual obligations. And there are a lot of laws across regions with regards to how long you maintain data. And sometimes you've got conflicting regulations because a business is in multiple countries. And then their lawyers have to figure out what is the best way to deal with it to be in close to compliance as possible with everyone else and have a justification for why they can't be, and or maybe even speak with regulators to see if that's appropriate, because there's various regulations that don't always agree with each other or jive with each other across regions. Now, how long do you retain the data? That can also determine on the sensitivity of the data. If data is so sensitive and can potentially hurt you, you may want to destroy that data after it's consumed immediately. Kind of like in the movie Mission Impossible, this message will self-destruct and you see the little smoke coming out of there. There's a reason that's highly sensitive data. So data classifications are what we're going to use to determine, in many cases, data retention. Now, when we archive data, we have to specify how we want to do it. Is the data going to be encrypted? If so, what kind of encrypted? Is the data going to be placed in an immutable environment, meaning it can't be changed, or just standard storage? If it's super sensitive, what kind of encryption strategy do we need to go? Do we need to go way above normal encryption? Same thing with data deletion. How am I going to delete our data? I promise you, you can delete your data more securely in the data center than you can the cloud provider. I can tell you that right now. On the cloud provider, when you delete your data, you can use some form of e-shredding of your data. In your data center, you can e-shred your data. You can write over that operating system zeros and ones a whole bunch of times. Then when you're done with that, you can drill holes through the hard drives. And then after that, you can throw it into a fire. I mean, depending upon when you get the point, you've got more control in your data center. So whatever you do with data, make sure it's disposed of properly. But before you dispose of data, make sure there's no legal holds on the data, or there's nothing to preclude you from deleting data, because sometimes the regulation-wise there could be too. So you got to make sure you're deleting data for the right reasons, and you're not getting rid of evidence, for example. So let's talk a little bit about data retention and archival. So we're going to always be looking for ways that we can enable data retention, our data when we retrieve our data, to correct anything that needs to happen. Because things may happen, it might get there, but we need good data. And we need good data in our disaster recovery environments. We need good data for our business intelligence tools. So if we're going to pull data or retrieve data, we have to have an efficient means to do it. Cost effective, but also working well effective. So when we're dealing with data and we're archiving it, we should test, can we store it? Can we pull it to make sure our processes work and our software packages work? So there's that. So let's talk a little bit about data retention, monitoring, maintenance, and enforcement. We need to do a policy review. So when we're dealing with data retention, we need to look at the policies they actually have. Are the policies good? Keep it. If not, amend or change the policies. We need to define responsible individuals or entities. We need to detail consequences for non-compliance, and we have to identify the enforcing entity in the organization. This, when we're talking about security architects and we're talking working with the team creation of the security policy, this is the kind of thing we do as security architects, a lot of this kind of work, working with lots of people for this. So let's address retention, deletion, and archiving in the cloud. Cloud models vary from, figure of software as a service, where basically you set your own backup and retention policies, to the full-scale hosted data center, infrastructure as a service, where we built custom solutions. Managing our data in the cloud is a little more challenging because it's automatically replicated to a lot of places. So we don't necessarily know where it's going to be replicated, or at least we have to plan that out. We have to ensure that cloud providers do not retain data longer than we want them to. And things with regards to cloud storage, that replicates here, 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 and here. And that way it's available should they need it. And you can get it to it. But it's making it very hard to find where your data is and make sure that it's actually truly deleted. So when a company negotiates with the cloud provider, they have to understand the data management processes of the cloud provider, their data management styles and approaches when they're actually needed. And you'll have to make the decision of what kind of archival purposes you would use. So maybe a business, let's say they're in AWS, they use AWS S3 for stuff that they access all the time. Then they move it over to S3 and frequent access, which is where you pay less to store it, but you pay to retrieve it, more to retrieve your data. And then when they don't use the data anymore, they move it over to something called Glacier, which is basically the same storage, but now you can't get access to it immediately unless you pay to access your data, but it costs you much less to store it there. So we can be thinking about lifecycle policies like that, how we archive data in the cloud. Azure obviously has the same thing. Google has the same options as well. But whatever decisions we make, they should be based upon the usage of our data, any chosen access model we use, and our policy should be able to dictate, where the data is going to be available, how long it's going to be available, and when the data is going to be destroyed. So it is critical for us as cloud security architects and cloud architects to understand how cloud providers remove data from their systems. How does a cloud provider deprovision their systems? When they deprovision their systems, do they toss their drives away? Do they degauss their drives? Do they basically write over the data, shred the data, and then burn them? How do they get rid of these systems? And we need to be very careful of that and figure these things out and ask these questions. Because we want to make sure that there's no remnant data that's accessible to other users. Data that's recoverable after the data has been deleted. And depending how the data has been deleted, it can either be easily recoverable or not recoverable. So we have to make sure that the system is designed the way we need it to be. All right. I think Mark and I should stop and answer some questions for a few minutes. Make sure everybody's on track.
All right, let's bring in our first question. And this is from Toyin. They're wondering, I usually am confused by this. Can you explain the difference between portability, interoperability, and reversibility? Mike, if you don't mind, I'll take a stab at it first. Correct me anywhere where you like. Toyin, what I like to do when it comes to these type of things, I try to think of the word itself. If I'm thinking of something that is reversible, I'm generally looking at something that I can take back or undo. So in this case, what we're defining is, give you a very brief example. Let's say you have data in one of the cloud service providers. Let's pick Amazon. And now you've decided, you know what? I don't appreciate paying so much money every month for what I'm getting back from Amazon. So you're deciding now that you want to reverse your original decision of going into the cloud. That is part of what we would consider a form of reversibility. Basically mean you want to stop using AWS services and now you want to move back to, let's say, an on-premise data center. So think of something that you can undo. Now, when it comes to portability, what does that word instill in you? It would mean something that I can easily pick up and move from one place to another place. If we were to think of that in context of, let's say, the cloud itself, that means I want to have the ability to take any of my data, any of my services, and say, you know what? What about if I wanted to move over back to my private data center? I should be able to do that without being forced to jump through too many hoops. So it's this, you don't want to have significant effort in being able to do that, nor have downtime. Or perhaps I want to move a service or duplicate a service to another cloud service provider. That is also a form of needing that portability, basically that ease of movement from one spot to another spot, or in case of cloud service providers, one environment to another environment. Now, interoperability, well, that basically means that I want to be able to make sure that one system can communicate freely with the other system, meaning I don't want to have some type of vendor lock-in, let's say where only Cisco devices can speak to Cisco devices. Or if I have a particular database that I'm running in Amazon, I want to have that database also potentially be talkative to something that I'm running on, let's say, a Google Cloud platform. In a sense, I want to have the ability to communicate, to exchange components and data. And I want that to be something that's seamless, meaning, again, I don't want to have a lot of trouble in doing so. Yeah. You can let me know in the chat if that makes a little bit more sense in regards to that type of structure, but try to break down the actual wording that they're using and try to apply to something that is more humanized for you in that sense. Yeah. All right, let's take a look at our next question here. And this is from Beatrice. They're wondering, how do we handle data protection in a multi-cloud environment? Beatrice, this is one of those topics that is going to span from basically the first day of our session all the way to the last day, because it's going to involve everything from, number one, what Mike's been talking about, how do we classify data, and then the different encryption, basically how do we provide confidentiality of data. Different things such as data loss prevention are going to come in. We also have to discuss some security best practices when it comes to policies. Things such as data backup. That's also going to be crucial in regards when we think about working with data protection. Mike already was touching on some of it in regards to also what happens, how is our data handled if we need to actually erase it. That's going to be part of that as well. And there's also going to be, of course, how do we deal with, Mike touched on it briefly in regards to the different vendors. There's going to be also, what do we do when it comes to incident responses? We're also going to have to discuss, of course, governance and compliance when it comes to these things as well. So I ask you, please stick around when it comes to the remaining, well, let's do 8.5 days since we're already a few hours into our session today, and you'll get a more holistic idea of exactly how we can go about handling data protection, especially when it comes to a multi-cloud environment.
Yes, but Beatrice, I want to add one thing to make it easier.
Mhm.
For the last 30 years, we've had companies that had three data centers and they had networking between them and shared data between them. Whether we're dealing with three data centers or three cloud providers, nothing changes. So it's the same tools. Who has access to what route? For example, we can what's firewalled off from whatever. What kind of encryption is going on that network? So, three clouds, three data centers, and we've never really only ever had a single data center because it was a single point of failure. So none of this multi-cloud stuff is new. As long as you don't use those cloud providers' native tools as a general rule, and as long as you use industrial security tools, like the kind you get from Palo Alto, Fortinet, Cisco, Checkpoint, that kind of thing, you don't really have any interoperability problems across your cloud. It's only when you start using cloud provider proprietary tools that make it very hard for you to go one cloud provider to another, get in, get out. It changes everything.
All right, let's take a look at the next question. Is a SIEM, a security information event management system, also a data aggregator? Is it a good tool to work with unstructured data? No. And the short answer is no, but let me explain this. So when we think about a system such as a SIEM, what we're really talking about is an aggregation point, generally speaking, when it comes to log data. And log data generally has context included with it, which provides us some type of structure. When it comes to unstructured data, because now we're missing this type of contextual information, if you think about like emails, if you think about like documents, it creates these funky kind of blind spots within our actual SIEM systems because the SIEM system doesn't really know how to handle the data exactly. And then on top of that, generally when we think about unstructured data, and Mike kind of alluded that to already, what we're looking is to do some type of analysis of that data. And that's not where SIEM systems generally excel at doing. It's a very similar idea when we think about SIEMs not having the ability to have some type of orchestration and automation as well as response. What we would do is we would add an additional system to it that can actually do those particular tasks, if you want to think of them that way. So, for example, in this case, what you would be looking for is more of a security platform that is tailored at looking at something like data discovery, classification, and as maybe something like threat detection. So you're going to look at something that's more security specific that can deal with the analysis of the actual unstructured data. Right? And I believe we had a follow-up question from Cloudy. Let's tackle that. They said, so data being portable does not necessarily mean the data is interoperable.
Yes, and Cloudy, I have a lot of experience with this. So when we deal with healthcare, we talk about health HIPAA, we're talking about information portability. So let's say Mark is the chief information officer of Hospital A, and Hospital A is using the Cerner electronic health record. And Hospital B is my hospital, and I'm using Allscripts eClinicalWorks. There may not be interoperability between my system and his system, but the data is still portable. And here's what I mean by this. The patient leaves my healthcare system. I can print out all their medical records and hand them a folder of their medical records. They could then go to Mark. Mark can have someone take their medical records and then enter that information into the new electronic healthcare record. Now, there was a manual intervention process to take that data from point A to point B, but that patient record, which is the patient data, is still portable. So generally speaking, if we make it very interoperable, it'll be very easily to be portable. But we can have portability without interoperability, definitely.
All right, and I believe we have one more question before we can get back to the content. I believe take a look. Okay, so we seem to have a few. The question is, so a cert, talking about a digital certificate, manages permission on a per user basis. If you don't mind, let me add something to it, just to kind of explain. So generally, when we discuss anything digital certificates related, we're talking in the context of a server client type of model. If you think of it like your computer trying to gain a website or a web page. Generally speaking, in that type of model, what you're looking to do is use that digital certificate just to authenticate that the server is who it claims to be. Now, what generally is recommended, and this is not best practice, especially if you look at some of the new security frameworks, and I say new loosely, but let's say within the 10, 15 years, there's a big drive to make sure that we have mutual authentication between the server and the client. In this case, it could mean that this is the user itself and another system. That way that we're not just simply making the assumption that both entities, in a sense, can communicate with one another. But that's an additional implementation step, and you would have to check with the systems that you're using if that's even something that is possible. It might require updating the platform or making sure something as simple as on, let's say, on the web server, making sure that you actually, it literally is just a checkbox of making sure that the server also will be authenticating the client itself. So this is not always done by default, just so that everybody knows.
Yeah.
But this is a very popular method when it comes to the zero trust architecture, where we will be using digital certificates as a form or as a single step in the actual authentication process. And that can also extend not just to the user, this will also extend to devices. So think about your PCs, your laptops, your cell phones, your tablets, etc. And then the question is, what is the fee to take the certification, the CCSP certification? Let me take a look here exactly.
Mark, I'm pretty sure it's $5.99 in the US.
Yes, it is.
Which is on the lower end of the price of the bigger certifications, and it's obviously higher than the less valuable certifications. And what's the CCI exam, Mark, now? $1,500?
Actually, it's $1,600.
So the CCI is $1,600. I believe the CISSP is $749. This one is $599, but in Europe it might be 599 euros. It depends on where you're at. So this is kind of that mid-price. As you start getting into the bigger certifications, they tend to cost a lot more. One thing that I can say is if you're properly trained for this, you should be able to pass it, as opposed to the CCIE that even with the proper training, the average person takes it 2 to 3 times before they pass it. And taking an exam that's $1,600 3 times is pretty horrible, because it's not just the cost of the exams, it's the airplane flights to be able to take the exams, the hotel stays that are even necessary to take the exams, and all the amount of crazy preparation that goes into that, and that costs as much as a car. So when all is said and done, so I wish it was cheaper, but at the same time, it keeps the number of people that actually pass this. The CISSP is $749, the CISM is $750, the CCSP is $599. All the good certifications that people are going to see and say, wow, they all cost a lot. And they're also much harder than the average certification, because the reason they stand out is you have to know something to pass them. And more, in addition to just knowing something, the exams are harder and they require much more thinking and much more application of the knowledge. So they make you more prepared to be able to do the job.
Yeah. And to add a little bit of context, if you look at some of these, what we call associate certifications, such as the CCNA and otherwise, what you'll notice, they're about $300 and plus to take. Yeah. And what notoriety you get out of it, or reputation that you build from, let's say, a CCNA compared to a CISSP or CCSP, is night and day. The CCSP will eclipse your brand compared to a CCNA.
Yeah.
So if you really think about it, $300 or $600, and what you gain for those $600 when you pass the exam is night and day. So I don't want you guys thinking so much about just what I need to pay for it. There's always going to be a fee associated with it. The best thing is to plan on not having to take it multiple times so that you don't go in that revolving door. When we took the CCIE, we generally say nobody wants to go take a $1,600 lunch, because that was the kind of internal joke that we all had, because they give you a little sub sandwich, and if you didn't pass, hey, you got a $1,600 lunch.
Yep.
And I believe, I don't believe we have any further questions here, so. But if any of you do have questions, we're always curious to see what type of questions you are. Make sure you write them down if you're in the middle of the presentation, or as always, you're welcome to put them in the chat box as well. So if you guys could give us another hashtag CCSP, just so we know that you are wide awake, especially when we're talking about minute details when it comes to data hygiene and how we classify and label data and how we eventually go through retention and so forth.
Absolutely. So hashtag CCSP. As a reminder, if you haven't downloaded the completely free book that goes with it, you can obviously get our book. My team has popped it throughout this webinar. The link to how to download the book. It should also be in the description of some of our videos, because we really want you to get as much as you possibly can out of this, including take-home materials and work to do at home and lessons to learning. Or we want so much for you. So there's that. So now I'm going to get involved in the next topic, which is legal holds. And as you can see, I hope you're sensing the difference between these professional level exams. We're talking about data classification and data strategies and laws and how these cloud computing models work. That's because this is an architecture for focused certification, so it's focused on more of these businessy things. So let's talk about legal holds. So there will be a time when you work in a business and that business is being sued. And if a business, it's going to happen constantly. There's lots of reasons people sue businesses, but for whatever the case is, you inevitably will be part of a company that will be sued at some point. Kind of like somebody sued McDonald's because they drank coffee and burned themselves because the coffee was hot, so they sued McDonald's. I would have known coffee was hot, but apparently a jury awarded them $3 million or something like that many years ago. So organizations, specifically big businesses that are big targets, may be sued from time to time. So one of the things going to happen as soon as a lawsuit comes in, you can't start deleting data. Because if a business starts deleting data, either they're deleting evidence, which, oh boy, that's a real legal nightmare. They'll have punitive damages and all kinds of big problems if the businesses doesn't work. So, or, maybe the SEC is going through an organization's banking records. It sees transactions and trades it doesn't like, and it's now a criminal thing. Again, it's going to be the same thing. There's going to be a legal hold on the data, and that legal hold means the data will need to be collected, preserved, and potentially deviating from your normal data retention and data destruction processes, because now you need to keep it. So a legal hold process is typically triggered from a notification from law enforcement, a regulatory entity, or private litigation. So if an organization is just naturally destroying data and all of a sudden a legal hold comes in, they can no longer destroy any more data. They have to keep that data, maintain it. So that may force the engineers that are that would have been in the process of deleting the data through normal data destruction means, based on times or automated systems, they will have to sit back, go back into those systems and stop the data deletion, data destruction, what have you. So we have to think, there's a precedence for legal holds. So organization has a security policy, a legal hold comes in, security policy is no longer in action. They have to comply with that legal hold. So in the US, there's federal evidence rules that will literally dictate how the legal hold takes precedence over other laws. So for example, let's say a hospital is trying to protect patient privacy. And now something else comes in where there's a legal hold. They may have to give information that would no longer protect that patient's privacy. So think about that. And think about the precedence of legal holds and the fact that they take precedence. Let's talk a little bit about data audit and audit mechanisms. So organizations constantly need to review their data. They need to inventory their data, see what they have, right? They need to inspect the utilization of their data, the condition of their data, the health of their data. Now, this doesn't matter if they're in a private data center or a private cloud like an OpenStack cloud or Nutanix cloud, or if they're in the public cloud. Same thing. So Talk a little bit about data audit and audit mechanisms. So organizations need a well-defined data audit policy. That policy should include audit periods. It should specify the frequency of the audits. It should specify the scope of the audits. It should define what data and what systems are going to be audited. It will define the responsibilities of the audit and determine whether the audits need to be conducted internally, externally, or both. So prior to an audit, there should be strong audit processes and procedures. And we need to detail the methods that are used for conducting the audits. So let's look at applicable regulations. Because whatever audit mechanism we need are going to have to comply with any rules and regulations. Now, if we're doing an audit, we need to monitor systems. So we need to determine how the audit will be monitored, what kind of maintenance is going to be done during the audit, how do we enforce the audit, making sure people get the information they need to in the audit. So when we're dealing with a data audit, we need logging. So what are we going to log? Well, we need event logging. We're going to see what's going on. We need security logging. We might need to log what kind of traffic, what's going from point A to point B in the system. We may have logs generated by our applications, logs generated by our operating systems, logs generated by our routers, our switches, our firewalls, our IDS, IPS systems. I hope you're getting the concept. We're going to need a lot of logs. And at some point, we may want to review these logs. And log analysis and log review, that's a job for somebody that's actually trained in this kind of thing. But there's lots of tools. When the person asked about SIEM systems, this is where SIEM systems are actually used. They're going to take all these logs from all these various systems. And that way, if something happens, like a security event, it will be able to correlate all these things in a log. Or somebody made a change to a router in Japan, and that affected the routing table on routers and 10,000 routes across that business on the world, and it took down the systems for 30 minutes. They can find what the actual cause was. So that's why we're using SIEM systems. But the people that are reviewing the logs need to understand what these systems are. For example, if you go to your Linux system and you got all these logs and warnings, but you don't know what they mean, you're not going to be able to do something with it. And when we're dealing with logs in cloud, we may think that certain logging services may need a specific logging capability or a format or a syntax, and we need to make sure we can make that work. So when it comes to logs, we've got to have a priority over reviews. So if we really think about it, in most cases, looking through logs is not something an organization typically does. Then again, most organizations don't know they've been hacked for months after they've actually been hacked, unless it's some kind of a ransomware thing where it's immediately obvious to them, where they have a DDoS attack. But log review in most cases just becomes an additional duty of someone. But here, you got 5 minutes, here, go check into this while you're actually at it. Sometimes it can be automated. So I want you to think about the magnitude of these logs. If an organization has 50,000 servers, and each one of these servers generates 100 logs per minute, and they have 10,000 routers, and these routers generate, 5 logs per minute, and then they have a bunch of IDS, IPS systems and firewalls that are logging, 50 logs a second. Some of these firewalls can be logging in depending upon where they're at. You're going to have logging systems coming from everywhere. So it's going to be very hard to really mine through these logs. People that have good scripting and automation services to mine through these logs definitely can help. But now there's commercial tools and SIEM systems which can really help with log analysis and review. And many of them have built-in AI too. Because the amount of logs that people will see and the amount of repetition in the logs will make it impossible to actually think and analyze if not filtered properly in the world absent of AI tools. So let's think about some of these challenges in log management. Well, for one thing, we need to have some degree of operational understanding. The people need to have a big understanding of the difference between what is authorized activity versus what is unauthorized activity. Because if they can't see it in the logs, they're not adding any security value. And we need to think about logs. It can get kind of cost effective. So it can require additional storage. And also the cloud providers actually charge us for the logs. So typically speaking, on a normal system in your data center, your system spews whatever logs you want to tell it to, and you can tell it logging frequency, etc. On the cloud, you typically get basic logging every few minutes for free and basic event metrics about your systems. But if you need a lot more detail of what's going on every 30 seconds with the CPU, the DRAM, or something more, you have to pay extra in the cloud to get that level of log. So logs can get there. They can be software. They can require significant storage costs and additional software costs trying to mine through and kind of look at this. So we'll briefly talk about effective log management. The logs needed to have an audit and review frequency. They will be checked this often by this many people to this time, completed in this time, what have you. We need to think about the responsibilities and the process of defining who will review the logs and what's the process to do so. Line by line, review it with 10 people. One person does it, the next person checks it. I don't know, what's the process? And we need to think about cloud logging variability. And the point here is the logging capabilities of the cloud provider vary very much from cloud provider to cloud provider. The providers themselves may not disclose the underlying logs that you actually need for security or liability for competitive reasons. They may not want to tell you how often their systems are being hacked or how many hacking events they prevent per day or little individual compromises. You're not going to see it. They're not going to give you that underlying infrastructure. You're not going to see their SIEM systems. So they could be getting hacked and not even know it, which means you could be getting hacked too. So I'm not saying that we shouldn't use the cloud. I'm saying these are the decisions that the security architect and the business and the CIO and the CISO needs to think about. There's no bad tools. It's about using the right tool for the right job. Now, we might actually have some contracts that are necessary to deal with regards to audit. So if we're going to move our systems to the cloud, there's certain things we may need to be able to audit. Now, how much auditing can you do of the cloud provider? Can you knock on the door and walk in and actually look and see how their servers are plugged in and go to the routers and look at their routing tables and look at their switches? No. Your auditing capabilities of the cloud providers are very limited. There may be some public auditors that you can use that you can review their things, but you're not going to be able to really understand what they're actually doing. So you can put a specific audit in a contract, and you can make sure that you can ask that the cloud provider meets certain legal obligations, but you're not going to be able to, in regards to how they do the logs, what they're looking for, but you're not going to be able to see it because you can't really physically go into them. So you can at least establish robust guidelines or specifics on what your expectations are across all your environments. Now, how do we collect these logs? Well, we have to think about the environment we're using. Most cloud companies have their own logging tools, like CloudWatch. Sounds great, right? What happens when you're using AWS, Azure, and Google, and you've got your data center? So now you're going to need a more commercial, industrialized logging tool that you can use on your own systems in all three clouds plus your two data centers, for example. So you can use industrial systems that work across clouds. You could use the cloud provider's native tool. But if you use the cloud provider's native tools, good luck trying to figure out and correlate all these things from three different tool systems, unless your SIEM systems collect everything from each one of them and sort of normalize them somehow. So why do we need to correlate the logs? So if we just collect logs, what are we really gaining? We're seeing what's going on in each system. I want you to think about this. 1,000 applications, 25,000 servers, 50,000 IP addresses, 5,000 routes in the routing table. This is your enterprise environment. Now, in an environment like this, one little trigger can trigger things thousands of miles away. And when you're dealing with something that's this big and enterprise-wide, sometimes you break something and don't even know how you broke it. And the only way you can find it is somebody goes through the logs and found out that this server in Hamburg, Germany disconnected 30 seconds after somebody in Cape Town, South Africa made a configuration change on a router. Sometimes this happens. And the only way you can find it is looking for the logs. The other side of it is something breached the firewall here. After the firewall was breached, something attached to this system. This system then attached to this system in a backdoor-like environment, and now the whole systems were compromised. You learn how they created the attack. You learn which systems were compromised too. So we can't just collect the logs. We've got to look at the logs and determine what happened to each other. So think about this. What if all your systems are on different time zones? Or they're not all using the same time? So Mark's computer right now, or Mark's phone or watch right now says 4:42. Mine says 4:41, and Chris is at 4:40. You think we can correlate these logs now? No, we can't. So typically speaking, these systems are going to synchronize to the network time protocol, which is going to synchronize all clocks across the world in your systems. And you typically use, say, UTC, or you pick a time zone and everything is in that time zone. So think about that when you're correlating your logs. It all has to be in the same time. If you don't set up network time protocol to work, everything's going to be on different times. How do you correlate them? Obviously, correlation is going to be a lot easier in a single cloud provider, but there's SIEM systems and SIEM tools which will ingest the logs from various providers and help you correlate events across clouds. So it's about using the appropriate industrial tools. How do you determine the appropriate tools and the appropriate SIEM systems? You have to determine what your business requirements are, the organization's needs, the organization's goals. Then after that, that's when we can evaluate which of the options we have, which one fits best for our unique business needs, and then evaluate all the strengths and weaknesses of each approach and pick the best choice, because there's never a best tech. So I want you to think about that. Now, other things we may need to do is actually look and see what's going on in the network. So we may get some network information from, say, Cisco NetFlow type data or VPC flow logs, where it tells me this system is talking to this system and protocol and port number. We may also want to have some kind of equivalent where we have a protocol analyzer or a sniffer capturing data at all times, maybe running that data to something like an IDS IPS system at the same time as we're analyzing it. So that's something we might want to do. It's a lot harder to do a packet capture in the cloud than it is in your data center, because you don't have access to the switch. You can't create a span port. Now, there are traffic mirroring options in the cloud. We can also create cloud VPCs and inspection VPCs in the cloud to kind of see what's going on with our traffic. But adding that adds a whole lot of complexity, and it adds cost too, because now we're dealing with inter VPC traffic charges, which we might have to do to be able to inspect the traffic going out to the internet, for example. So we have to deal with pretty big workarounds to make some of that stuff happen on the cloud. So if we're dealing with a SaaS environment like the Google Office or Microsoft Office 365, it's going to be near impossible or impractical in most cases to get a packet capture on the network. If I'm using a Lambda function or a platform as a service type function or a function as a service, I'm not going to be able to understand anything what's going on across the cloud provider's data. But if I were to create I could create a VPC or my own virtual private data center, and I could have traffic coming into that VPC, and I can use that going out to the internet and create a server that's going to be doing packet sniffing the whole time. I can do it. So there's workarounds in the cloud. Everything in the cloud is a workaround to get to the same level of security and performance we have in the data center, because it's virtual versus physical. And when we deal with virtual, we got a lot of workarounds because the cloud's built for common use cases where we may need specific use cases. Now, if we're using an infrastructure as a service environment and our transit VPCs and our traffic inspection stations, VPCs, which we can make, in infrastructure as a service, we have the ability to capture much more information. But even within infrastructure as a service, traditional packet capture methods are not necessarily technically feasible. And there's lots of commercial grade packet protocol analyzers I've used throughout my career. There's also the free one, Wireshark, which I think Cisco owns and puts out there. It does great at packet capture and simple analysis. Now there's lots of opportunities, and when we're trying to audit and we're trying to capture, please understand you will be very limited in here. So it'll be on some things, but not other things. For example, you're not going to run a packet capture on the database in most cases. So it's going to be very limited what you can do. Let me see how much I have in this content. Bear with me. And then in the next section. Okay, we can do it. Okay, so we're going to talk about some data destruction and some data disposal. In an on-premise environment, data destruction and disposal is really easy. We shred the data, we overwrite the hard drives, and we basically, put it in a bucket and light the hard drives on fire or something like that, or we have it compacted. It's no big deal to destroy them. But in the cloud, that gets a lot more complicated, because they're not going to destroy their drives after you deleted your data from it. So normally we destroy our hardware, we melt it, we impact beat it, we drill through it, grind it, and we shred them with industrial shredders. We can also degauss them, take large magnets and erase stuff. In fact, many people used to do that. They had videotapes many years ago, and they'd run these big giant magnets, and basically that would erase the tape, and they would record right over it without getting the old remnant data. That was something they used to use. But we can do that with some media, but we're not going to be degaussing an SSD drive, flash media, or USB thumb drives, because they're not magnetic drives. The magnetic degaussing worked for the spinning hard drives, the traditional hard drive, for example. So other ways we can get rid of data is we can overwrite the data. So my data is a photo of my cat, Cindy. That's the data. She's sleeping. She looks cute. Now, if I delete it, somebody else that has that could actually see that data and recover my cat photo, Cindy. Again, it's my cat photo, Cindy. I'm happy for the world to see her. No big deal. But what if that's proprietary business data? So what we need to do here is, for the most part, overwrite that data, and overwrite that data. So if I've got a data of Cindy the cat, I delete that data, I write that hard drive with, say, all ones, and then I erase it, and then I write it with all zeros, and then I write it with all ones, and then I write it with all zeros. Now, that's less effective on SSD drives, which and a lot of the storage now, but we can do it to a degree. Crypto shredding is what we're going to be able to do in the cloud provider, and that's basically where we take our data and we encrypt it with very strong encryption, and then we destroy the encryption key so nobody can access the data. So in the cloud provider, this is going to be more effective than overwriting, because the data is almost never going to be able to come back from the strong degree encryption if you use good encryption keys. But the downside here is to encrypt with that level of encryption, it's going to take a lot of CPU performance and overhead. So it's going to eat up our server's capabilities on just encryption. Now, let's talk about in a SaaS or a PaaS environment. Well, now in this particular environment, we're now in a real issue, because in a SaaS environment, we really don't have a lot of ability. We can't overwrite the storage. So the only thing we have is through contractual means, and we can hope that the cloud providers actually destroy whatever we want them to. But in most cases with the cloud crypto shredding, where we encrypt it with that strong encryption, and then we destroy the encryption key, is going to be our best option. No matter what, an organization is going to need a strong policy on data destruction and data disposal. It will need a policy that talks about the process to dispose of data, the detailed steps necessary to dispose of data, any rules or regulations that could govern the destruction or the disposal of that data, any data destruction timing things, and any kind of guidelines. We need to make sure we have these things. A little more about crypto shattering. It's relatively effective because it leaves no remnants or little bits of the data that's there. But anytime we have any remnants of data or data that's left after sanitation, we want to make sure that we encrypt everything and then destroy the encryption keys. So I think now is a really good time, because the next thing we'll be talking about tomorrow is cloud data security. Now is a really good time to stop, take questions, because we were going to finish in 9 minutes anyway. So let's see who has questions.
All right, let's take a look at what questions we have. So from Noble, with data hygiene and labeling, will you consider Microsoft Purview to be a good tool? Noble, good is relative. Give you an example what I mean with that. If I was part of a single cloud service provider's platform, in this case, since you mentioned Microsoft Purview, let's go with Microsoft Azure. Then it would be a great tool, especially when it comes to governance and compliance, right? It's going to give us the data labeling, the hygiene. It's going to allow us to integrate in additional security tools. But with about, and I believe Mike can correct me if I'm wrong with this, I believe it's about 98% of organizations are multi-cloud, I believe.
Yep.
And
enterprises.
From that is that correct, Mike, roughly around there?
98% of enterprises, yes.
Enterprise, yeah. So from that perspective, and I'm going to ask you this, Noble, and you can answer in the chat as well. Would it still be the best tool to use if I have data that is spread across 3 different cloud providers? And that's where it always comes to this notion, good or bad, there is no such thing as good or bad. What is the best tool for the job? And since there's such a high amount of people and enterprises that are in a multi-cloud environment, you never ever want to be kind of getting yourself into this idea of vendor lock-in. So you're better off perhaps going with more like an open source type of a tool, or just a tool that was designed to work in these various environments. And I believe one of the tools, I think it's called Informatica, if I remember correctly, and Big ID, if I remember those two correctly. So those are tools that allow you visibility into the different cloud providers. So that way that you have the ability to actually manage your data across a multi-cloud environment. So again, it depends on what you're trying to do. But if you're going to be multi-cloud, Purview, perhaps not the best tool for the job. If you're single cloud, and it's specifically Microsoft Azure, it's probably the best thing since sliced bread, if you ask Microsoft, for what you need to do.
And Noble, I want to add just a touch to this. When it comes to tools, there's no such thing as a good tool or a bad tool. There's the right tool for the job. Until we truly understand the needs, we can't have it. So I'm going to use the concept of the architect right now. And I'm going to use the concept of a physician, or a nurse practitioner, or a physician assistant, because that was my old life. If somebody asked me, is Lipitor a good pill? I'd say, for what? And if the goal was to lower LDL, then I could say Lipitor is a good option to lower the LDL, or atorvastatin. If you ask me what I thought of Lipitor as a means to solve someone's breathing problems, I'd say it's the worst possible opportunity we ultimately have. Now, I might have someone that I might need something that's a little stronger than Lipitor or atorvastatin, depending upon what their LDL is, and I might use, say, Crestor, which is a little bit stronger, typically speaking, if I had a patient with worse LDL symptoms. I might also, if they had a low HDL, I might think about niacin or fenofibrate or other options that I could add to the regime. But I wouldn't be able to do that until I knew that person, I knew their risk factors, I knew all the medications they were taking, and knew every other problem they had inside of their body. When it comes to architecture, it's no different than medicine. Until you know the goals of that business, until you know the weaknesses and strengths of that business, until you know what those organizations' current systems are, until you know all of those organizations' needs and their business processes, We can't have any solution done ahead of time. There's no good product. There's no bad product. So I got to tell you, one product is going to do this really well, but it's going to be really bad at something else. The next product will be great at what that thing is something else is bad at, but it won't be as good in what it's good at. And the good choice in architecture or even engineering is what's the best option we have after we consider all the strengths, weaknesses of every option. And it's going to be a set of trade-offs. There's never, when you deal with a big enough environment, there's never going to be a good choice. It's okay, this option is an 8 out of 10, and this option is a 5 out of 10. Let's choose the 8 out of 10. This situation is a disaster. We've got a 5 out of 10 and another 5 out of 10. But this 5 out of 10 we're sure is going to work, and this 5 out of 10 we don't know. Choose the one we're sure of. So lots of times architecture is all about picking the right information after we know everything. And if we start out ahead of time, it's like a doctor that recommends surgery without even meeting the patient or knowing what they need. Same problem. Good question, Noble. 80% of technology projects fail, and that's the reason why.
Question from Cloudy. Do cloud providers provide you with a certificate of destruction when you're destroying data or disposing of it?
Generally speaking, every time you delete something, they're not going to give you a certificate of destruction.
Where they're going to excel in is in the standards when it comes to actually the destruction and disposal of your data. They're going to be sticking strict standards that they're going to abide towards to make sure that the data is actually destroyed. What you could do, in this case, Cloudy, since they generally don't do it, depending on what type of relationship you're going to be having with this cloud service provider, and just to give you a little bit idea behind IT in general, when you spend a certain amount of money with somebody, especially a vendor, they'll do things that they generally won't be advertising nationwide. So yes. Again, the recommendation would be there that get with your actual representative of whichever cloud provider that you're working with and float them that idea. Ask them, hey, listen, I need a certificate of destruction for my data or disposal. Is this something that perhaps we can work up? Would this be a possibility? And then see, of course, what they would tell you. But by default, like Mike said, with the amount of data destruction that they probably do is they're not going to provide you individual certificates of doing so. All right, from Teddy Gady, they're asking, what time tomorrow are we talking about cloud data security?
So tomorrow we will discuss, our program will begin at 2 p.m. And realistically speaking, that will begin at 2 p.m., plus or minus 5 minutes or so. And actually, while we're at it, every day for the next 2 weeks, we'll all begin at 2 p.m., Eastern Standard Time.
Mm-hmm. From our dear Alonzo, he's asking, could we please share with our audience the differences in how the CCSP, the CISSP, and then, of course, the CISM can help their careers?
Yeah, so it all depends on one's career goals, and I'll kind of go over all three. If I was only allowed to pick one security certification, it would be the CISSP. And what is the CISSP? It's an all-around, very genetic. We cover just a little bit of absolutely everything at about this much depth. So here's the way I would describe it. Many people would describe the CISSP as a mile wide and an inch deep. It's kind of like the Security Plus, but I would say the Security Plus is 1/10 of a mile wide and 1/10 of an inch deep. So the CISSP is in that same vein. It's security fundamentals, but it's a lot wider and a lot deeper than, say, a Security Plus. Not that there's anything wrong with the Security Plus. It's a nice pre-fundamentals exam. So that's your CISSP. While the CISSP does a beautiful job at pretty much every little thing you might want to think about in cloud computing, and then you can build your entire career in any one of those topics that it talks about, it's a little weak on cloud computing as it stands today. The CCSP is a slimmed down, more junior version of the CISSP, with a huge emphasis on cloud computing and the challenges in cloud computing. So, skinny version of the CISSP, big, strong, powerful when you start thinking about cloud and security issues that ensue in the cloud. The CISM really comes about it and makes you think about it from the managerial perspective. It's more business oriented than the CCSP or the CISSP. In my youth days as an architect, I started out with the CISSP because it was the king of all security architect certifications, especially for network security people like me. At this stage of my life, I'd rather take the CISM because I'm not really designing architectures directly for my clients, but I'm going to be evaluating these multi-million-dollar security things. As I moved into more executive architect roles, it became more about my ability to speak with decision makers and influence decision makers and have strategic conversations. And the CISM is a junior version of that, but at least it introduces more of the business concepts. So all three are good. I mean, if we had a security architect and they did all three, and then that was their three certifications that they had and they didn't have any others, and then they focused their system in knowledge design and business acumen and leadership, and they picked one subspecialty of that security architecture and dove deep, realize that those three certifications might be a good 30% of what they need. And then they can learn the other 70%, which is how do you put those pieces together. And the business skills, the CXO relevancy, the executive presence, the leadership skills, along with those fundamentals, and they'd be pretty in good shape.
Yep. And it's going to depend again on what you're after. And what I mean with that is if you're looking for a certification or some way to give you credibility based on the competency and the skill set that you have, and you are, let's just say, for example, you value the ability to pivot between different roles, I would definitely say that the CISSP is going to allow you that variety. That particular certification is going to allow you to be, if you want to, a security analyst. It's going to allow you to be a security architect. Yep. It has part of it is also leadership. So you're also going to be able to do something similar like the CISM, where you can get into, let's say, like a manager kind of role or director type of role. So that's what it's great at. But when it comes to, let's say, the CISM has a lot more to do with in regards to this governance and regulations and the way that the procedures are going to come out. So when it comes to CISM, generally speaking, what we're talking about, that you're going to be a chief information security officer. So you're going to be really high up on that income bracket. And on average, last time I looked at the different type of incomes or salaries that the CISSP compared to CSM kind of garner is, you're looking for about $120,000 to $125,000 for a CISSP role. So that's generally like an average. And for a CISM, because of this strategic perspective that you need and this really strong leadership in regards to that, you're generally looking for about $155,000 to $160,000, kind of like that average in the CISSM. So if you're looking to get the best bang for your buck and the most salary out of it, the CISM is going to be the role for you. When it comes to the CCSP, fantastic. But as we've always said, it is more of an add-on to all the security foundations that you would be building through the CISSP, and an extension really also what you would require for a CISM role, a managerial role, a leadership role. So I would not necessarily put them in the same category, but the CCSP is a very nice supplementary type of knowledge that you can add to both roles. That would be my
and the key
to 3 cents.
And the key to remember, it's not that a certification will get you a salary in the certification. We need to be very clear with this. It's people that hold these certifications in various roles that get it. So there's a lot of things that goes into it. For example, I love to hire CCIEs, and you know what? It has absolutely nothing to do with the CCIE certification. So when I hire a CCIE, here's what I know. I know that they are willing to go way above and beyond. I know they're willing to read the 50 to 75,000 pages of reading that's necessary. I know they're willing to spend at least 1,000 hours doing the labs. I know they're willing to invest $15,000 to $20,000 minimum into their education and their future development. I know that they're willing to forgo sleep for 1 to 2 years, to isolate themselves from friends and family members for 1 to 2 years because they want to be so good. And honestly, that's the person I'm looking to hire. Someone that's that hardworking, that meticulous, that loves it so much that they're willing to spend their time, their effort, and money into building their career. So there's that. When you deal with the cybersecurity architect, and they have the business skills, which gets them paid, the leadership skills, which gets them paid, the executive presence, which gets them paid, the business acumen, which gets them paid, the presentation skills that gets them paid, and the knowledge of the underlying technology and how to put it together. And they are the ones that will say, you know what? I want to build my brand. I'm not going to get 6 associate certifications that nobody cares about. I'm going to get these 2 or 3 big professional certifications. They're showing me they're willing to go above and beyond and do the hard stuff, the uncommon stuff that somebody else is not willing to do. That they're willing to dive deep. Now that makes me more likely to interview them. And those same people that are doing these big certifications are also self-motivated, self-learning, and they're learning in so many different places that they tend to be my best hires. So that's why you typically see these things. It's part of the whole package. And those 3 certifications are my 3 favorite in cybersecurity. They really are. In networking, it's simple. I got 2 favorite ones, the CCIE and the CCDE. Pretty simple. But in each field, there are certain ones. But as a rule, I'm not even sure that it makes sense. At some point, I was asked to remove the CCIE from my business cards because it created the wrong impression of me. It made me look like a techie. So I was told to take it down at a point in my career. So, Alonzo's point is good. We talked about it. But depending where you're at in your career will determine what you want on your brand and which certifications you will actually show. You want an $800,000 architect job? I promise you, they don't want to see your techie certifications at all. There's no certifications for the CIO or the CTO. By comparison, you want to get your first cloud security architect job and you have a CCSP and a CISSP and maybe a solutions architect professional, you're looking pretty nice on paper. So we have to determine the knowledge base and the training base, which is one thing. And then Alonzo's a marketing expert, which is probably why I asked this question. We have to build the brand. And the brand is based upon the actions that we actually take. Our brand is based upon the content we actually create. Our brand is based upon the papers and the certifications we show. Do we look like we're confused and we want to learn 50 other people's jobs? Or do we look laser focused on something? And that's why Alonzo, I'm sure, mentioned this, because these are good brand builders.
And the money is just to give you guys some incentive that you can make money with it. And Mike making a good point, and I sort of should have clarified myself, so I'm going to do it right now. When you see any type of salary associated with a certification, the assumption is made that you're really good at what you're doing. So there's a lot of underlying competency that you will have to check the boxes on to even get to a point where you can earn that type of salary. But keep that in mind. That's how that will be one motivating factor in which way you pivot is going to be the income. But of course, there's so much more that goes along with it. All right, let's take a look at the question from Alexander Henry. They're asking, would you advise to take the CCSP first before the CISSP?
What's your goal? Which job are you looking for? If we get that, we can give you some more information.
And while we wait for that response from Alexander, I just wanted to touch on what Noble mentioned in the chat in regards to his statement. Then an open source tool will be better. You can just read from here. Then an open source tool will be better when looking at it from a multi-cloud perspective. The answer is it still depends, but generally yes.
Yeah.
Go ahead, Mike.
So let's talk about the difference between an open source tool and a commercial tool that we can use on all clouds. So I can run the Oracle database, and with the Oracle database, I can run that proprietary database in AWS, Azure, Google, and any cloud that I want. And if I need an industrial enterprise grade database, there's a good chance that's the right one for me to use, and that is not open source. I could also use Microsoft SQL in every one of these environments, and again, it's going to be there. So I want to talk about that. Now let's talk about open source tool. I can get a completely free version of OpenShift, which is pretty much open standards, a cloud management platform. And guess what? If I get it that way, it comes with absolutely no support. I can't call anybody when it breaks, but I can build that open source Ansible cloud like that for free. By comparison, I might want to go to Nutanix, or I might want to go to IBM Red Hat for that. And by doing so, I could actually find myself in an actual position where I can have a supported cloud environment. So something that will function in all clouds, yes. Open standard, open tool, open source, not necessarily.
Yep.
And Wally, I'll get to your question, but I need to know what you want your job to be, because if you want it to be an architect, it's going to be completely different hands-on than an engineer, which is going to be different hands-on. And the labs, the hands-on is incredibly different for an airplane pilot, a physician, and an attorney. They all need different sets of hands-on experience. That's why I asked you what job.
Yeah. So when it comes to, it looks like Alexander, who fielded the earlier question in regards to which should I take first, the CCSP or the CSSP, he did mention he wanted to be a cybersecurity architect.
So Alexander, I would ask you this, what do you have access to? So if you have access to good cybersecurity training and you're only going to take one, and by access to good cybersecurity training, it's going to cost you between $7,000 and $10,000 minimum to take a good CISSP or a good CCSP bootcamp, minimum. And I was only going to take one, I would do the CISSP. Now, all the students in all of our cloud architect programs get access to the CISSP. But if I didn't want to spend the $5,000 to $7,000 on a good CISSP bootcamp, I would take the CCSP because it's almost as good, and we're giving you that grade of training, or better than you would get if you spent that $5,000 to $10,000 for that training. So I would do the CISSP if this is what you have access to, or the CCSP if this is what you have access to. Remember, as an architect, it's not about your certification, it's about your architect knowledge. It's about your architect skills. And what we do as architects is very different than engineers, so make sure you've got that architect skills, which I'll actually get to when I answer Willie's question, but although I still need to know which one he actually wants. And I'll get to Willie's question, and I'll answer it with regards to 3 different careers and explain why.
All right. In the meantime, let's go ahead and bring up Evelyn's question. She says, I'm currently an ISSO with a CISM certification or certificate. I also took training and got a certificate as a solution architect. I've been planning to study my CSSP, but not getting anywhere. And the follow-up is the CCSP is the next thing I want to take and then deal with the CISSP later.
Okay, couple things. So, one, Evelyn, what you were certified in as a solution architect has absolutely zero to do with solutions architecture. So please join us on the Thursday webinar on how to become a cloud architect. We will cover the solutions architect role. There is nothing in an AWS solutions architect professional that has anything to do with solutions architect. There's zero. It's 100% systems administration. So when I answers Willie's question, I'll actually answer yours. But the CCSP, the next thing, could be fantastic. It could be absolutely fantastic.
Right. I don't see a follow-up yet from Willie in regards to it.
But I'm gonna
but
I'm gonna answer that anyway.
okay, go ahead.
So Tyrone, put up Willie's question because this is a very dangerous question, and this is where most people actually damage their careers. He said, "Will this boot camp have any hands-on lab/activities? If not, what's the best way to get cloud experience if I'm not in the field currently?" Willie, we need to know where you're going. So, if you are a architect, a security architect, here's what hands-on experience means: responding to an RFI, RFP, RFQ, leading an architecture team, creation of an architecture repository, management and collaboration with stakeholders across an organization, learning the IT initiatives, business processes, and mapping the organization's people, processes, and technologies into a cohesive solution, looking at the current environment they are, determining what their current threats are, evaluating their current threat potential, and determining a plan of what you're going to do about it. In an architect job, if you learn how to code, if you learn how to configure, it will not teach you how to do anything for the architect. So if you're there setting up WordPress websites and playing with DevOps and writing code, it will not teach you anything related to architecture. By comparison, if your job was to be a cloud penetration tester, you're going to have to get down and dirty with Kali Linux tools. And I would tell you to build a server or buy a server, something with like 32 cores and 256 gigs of RAM. I'd tell you to pop a hypervisor on that server. I would tell you to build virtual machines on that server, Windows virtual machines, Windows servers, Linux virtual machines. I would tell you to set up a Kali Linux server and hack into those systems. I would tell you to set up an Active Directory server and get hands-on experience and try to break identity and access things. I would tell you to, on that same server, to build an EVE-NG server and create a network and hack into that network with your Kali Linux system. But that would be for a penetration tester. If I've got a cloud architect, I need to teach him how to give a presentation, how to manage some stakeholders, how to manage some vendors, how to respond to an RFP. That's their hands-on experience. By comparison, if I had a cloud engineer, I would need to get that cloud engineer hands-on the cloud, hands-on with infrastructure as code. I'd need to get them writing Python scripts and Bash shell scripts and Windows PowerShell shell scripts. I'd need that person to have good Linux engineering knowledge. Every one of these jobs needed a different set of skills. So we can't determine where your career is. But if you want to be an architect, I can promise you stop doing hands-on projects and then telling the world about all your hands-on projects. Because here's the thing. Here's what you're really saying. Hi, I'm an airplane pilot, but I worked as a flight attendant today. Look at me being a flight attendant. You know what people will see you as? A flight attendant. Flight attendants are very important people. But if you want to be seen as an airplane pilot, you don't want to be seen as the flight attendant. If you're serving food and you're great at it, and so it's not going to benefit you to learn how to be a chef. It would benefit you to learn how to pair certain foods with certain wines, and to develop your emotional intelligence and your ability to exercise influence, so you can run up a tab and you could get larger tips. But in every career, we have things that make us better. So I'd like you to see, where do you want to go? And then we can determine the experience. But if it's an architect, join us in the completely free webinar on Thursday. I kind of hope that kind of helps.
Yep. So as I said a little bit ago, we're going to take a stop here with the questions and answers. We'll be sure to eventually have a dedicated session where you can ask us a little bit more of the career development kind of questions if you have them.
Yeah.
And as I told Sergio in the chat, when it comes to anything legal, governance, or compliance, we will have a dedicated section that's part of the actual CCSP study guide, as well as this bootcamp, where we will address those things. Because there are some intricacies that we'll have to go into, especially when we're talking about trying to take data from one continent to another one, because it involves legalities that we'll have to address. But aside from that, for everybody, thank you very much for being here today. We really enjoyed ourselves. If you have not, make sure you like the video, share it with others. If you haven't subscribed to the channel yet, we hope that you will so. There's a lot more content to come, and there's some fantastic content already available for you when it comes to cloud architecture, network architecture, and as well as security architectures. Aside from that, As we keep going to remind everybody, there's a free study guide that you can find through the LinkedIn post that we shared earlier. If not, you can look in the description box below. Make sure you grab a copy of that study guide. It's going to serve as a supplemental to what we're doing here in the bootcamp. It can also serve as, think of it like a slide deck that you can follow along as Mike and I, we go through presentations and explanations of various things. And if you have not so and you are interested in a cloud architect career, especially if you want to break into technology field, be sure you sign up also for how to get your first cloud architect job webinar, which also you should find in the description box below. If not, a team member of ours will post it in the actual chat box. Do you have any closing statement, Mikes, for today?
I had fun getting to spend time with all of you all across the world. Make sure you download that completely free ebook while you're at it. If you've enjoyed this, in addition to liking it, maybe share the training with a friend. It costs a lot of money to put a program like this together. You don't realize that there's about 6 people behind the scenes. We're talking with CCIE grade people that are spending months of time to really try to do this. So we'd like people, no matter where they're at in the world, to be able to get training like this because we know most people can't afford it. So we're doing it free. So please share it. In any case, hope to see you all on Thursday if you desire to be an architect. And I'll also schedule a 2-hour session at some point in the next 2 weeks with Mark for career questions. We'll do it on Zoom, so we'll be able to answer any question you may have. So see you all tomorrow. And give me a hashtag CCSP. It's good for me to know that you're here. It's probably good for the algorithms as well. And again, please like, subscribe, and hit the bell to be notified of new videos to help you in your career. Take care, everyone.
Goodbye, everyone, and see you tomorrow at 2 p.m. Eastern Standard Time.